Thank you very much. Good morning. It's amazing to be here, and welcome back to this incredible Porter Tun room here at the brewery. You're sitting in the largest surviving building from the 18th century brewery, completed by Samuel Whitbread in 1784. Originally used for the fermentation of the malt liquor porter, I doubt when they constructed this room nearly 250 years ago, they could have considered that we would all be here today, a bunch of software developers learning about this thing called PHP. Yet, here we all are. And it's not just this room, but London itself has certainly changed over the years. Actually, incredibly so, just within our own lifetimes. This is a photo that I took on a school geography field trip back in the late 90s. If you've ever been on a school geography field trip in the UK, then you'll know the scene. There's rain in the air, clipboard in hand with soggy paper attached, usually some sort of questionnaire that needs to be completed by the end of the day. This particular field trip was not much different. I believe this photo was taken somewhere in the Mudshoot Farm area as we explored London's docklands as part of studying its regeneration plans. And despite many a rain-affected, cloudy field trip, I enjoyed geography through school, and that's what led me to take it on at degree level. And somehow, between then and now, I've ended up here. So, after graduating with a degree in geography in 2004, I then spent a couple of years working in an admin role for the local council, wondering what on earth I wanted to do with my life. And it was during this time that I discovered PHP. I taught myself by building a Formula One Fantasy League website. I caught the programming bug, and this led in 2007 to me starting my first web development role, working with PHP. And the rest, well, most of the more recent stuff at least, is in the Git history. So there I was, working away on PHP applications, forgetting all about geography. Until one day, about 5 years ago, I saw a quote from computer programmer Ellen Ullman on Twitter, and suddenly I made a connection between my degree and my now profession that I never had before. We build our computer systems the way we build our cities. Over time, without a plan, on top of ruins. This quote spoke to me, both as a geographer and as a software engineer. My two worlds colliding. Here was someone making a direct comparison between the built environment we're all inhabiting and the virtual environments we're all creating. And I think this picture does a really good job of representing it. Just over a year ago, archaeologists uncovered the largest Roman mosaic to be found in London in 50 years. In the foreground, Roman mosaic created approximately 1700 years ago. And in the background, the Shard, one of London's most modern buildings. Over time? Yeah. Without a plan? Well, the Romans couldn't really have planned for our present day. More likely, they would have had their own plans at the time they were creating this mosaic, and subsequent eras their own plans, and so on as times evolved. On top of ruins? Yeah, but in reaction to human evolution and progress. I wonder how many of you have ever felt like you've played the role of code archaeologist. Perhaps this picture rings true for some code bases you may have worked on. However, there's 1700 years between Roman mosaic and the Shard. And I'll hazard a guess that you may feel you've seen this type of transition in a code base within just a few short years. Perhaps due to speedy business growth or pivoting causing changing requirements and use cases, and resulting in the evolution of the code base. More than likely backed up by wider technological evolution and progress. So I do think that Ellen Ullman was onto something when comparing the evolution of cities with the evolution of computer systems. albeit on some sort of condensed timescales in our virtual worlds. And this led me to wonder what other evidence of such similarities exists. One of the outcomes of a constantly evolving, never finished city is that over time it can become an interesting patchwork of differing architectural styles. London is an amazing example of this. One minute you can be looking at Georgian architecture, the next modern glass-fronted skyscrapers, the next the brutalist concrete of the 1970s. And so it is in our virtual worlds that many different approaches and frameworks have been in and out of fashion over the years. Or months. I'm looking at you, JavaScript. And over time, a code base can come to reflect this. And whilst an eclectic mix of building styles may contribute positively to a city, within a code base this can actually be less favourable, because it adds to the cognitive load required to read and understand what's going on. I'll bet that most towns and cities of any great age will have somewhere close to their heart an old town. This is where the oldest buildings survive, perhaps today with preservation orders preventing their removal or significant modification. And today may be surviving on income generated from tourism rather than the local populations that they once served. I say close to a city's heart because oftentimes you'll find that the location of the modern day city centre has shifted to a nearby location where new developments such as shopping centres and entertainment facilities have been constructed on areas of land with fewer building constraints. The old town still exists, however, and must be maintained to ensure the continued success of the city. And so it is in our code bases that there will also often exist an old town. Or perhaps in our world, we'd do better to call it the legacy town. Somewhere close to the heart of our application is the code that contractor wrote on day one, still driving some core aspect of functionality, and today a creaking foundation on the critical business path that few people know the exact specifics of to be brave enough to make changes to. So it kind of takes on its own self-imposed preservation order. Around it, perhaps a secondary centre has sprung up, hosting the core of more recent functionality that bypasses the legacy town. Not all developments within a city will live forever. By its very nature, the evolution of a city will naturally involve, over time, the decline of some facilities. If buildings are left uncared for and abandoned, such decline can cause seriously negative effects on a city, including vandalism, crime, and general decrease in quality of life. If areas are left uncared for, however, the likelihood is that they will get worse. Other areas will also decline, or other facilities will also decline because no one wants to go to the area anymore, and the area will grow a negative reputation. Industrial decline in London's Docklands was what led to that field trip that I was on investigating the regeneration plans back in the 90s. In a code base, we call this dead code. Code for a feature that is not used anymore. Or maybe code for a feature we don't think is used anymore, causing confusion, red herrings, and making it harder to onboard new team members. In much the same way as an abandoned building, there will be a financial cost to removing the dead code. And this work will often take a lower priority when compared with other new features being requested by the business. Dead code is technical debt, however, and will likely ultimately catch up with us. As the number of people living in a city grows, so too does the need to house and support this expanding population. The growth of city suburbs, often with low-density housing and major reliance on the car, has led to the rapid and often unsustainable expansion of cities around the world, described by the term urban sprawl. Megacities are the result. Indeed, by some definitions, you're all sitting in a megacity right now. In the world of geography, studies are now looking at what various cities are doing with regard to spatial restructuring of a megacity. For example, creating more localized centres within the wider city region. The application equivalent of a megacity? Well, that has to be the monolith, right? Spatial restructuring? Think modularizing the monolith or microservices. And of course, if the urban sprawl of the monolith gets too much, then there may be a cry for the big rewrite, the chance to start again fresh and to do things right this time. If you live in one of these towns or cities, then you live in part of the biggest urban rewrite project in British history. Mid-20th century Britain's vision of utopia. In post-war London, there was not enough housing to support the growing population. They hadn't built any new houses in 6 years. The average age of marriage was decreasing, meaning more households and a higher birth rate. And there was also some pretty significant war damage. In response to this, the government launched an ambitious scheme. New towns would be developed. An experiment in urbanism using experimental design approaches. Initially mainly on sites surrounding London, but a few a bit further afield. The first new town, Stevenage, was built in 1946, which means today is approaching 80 years old. In 2021, the Town and Country Planning Association published a report into the future of these new towns. Summarising that, today, the new towns exhibit a range of successes and failures, including as they do both the fastest growing, most successful places, yet also some of the most deprived communities in the UK. And most assessments are similar to this. Although they may have provided a utopian, dreamlike environment for their initial inhabitants, today these towns are not new anymore and exhibit just as many challenges as other towns and cities. So, despite some successes, it turns out that the big rewrite wasn't quite ultimately as utopian as initially envisaged. So, whether it's the design styles, the legacy old town, the dead code of abandoned buildings, the urban sprawl of the monolith, or the utopian rewrite, it really does appear that, in some ways at least, you can compare the evolution of cities with the evolution of computer systems. And this led me to wonder, what insight might we gain from the world of geography? Within geography, cities are studied under the subdiscipline of urban geography. Within this, there are two approaches to study. The first is the study of systems of cities. Here, the focus is on the distribution of and interactions between cities. The second approach is the study of the city as a system. Here, the focus is on the internal structures within cities. And it's this second approach that I'm going to focus on. I'm going to start by talking about two key components of a city. The first is people. People are pretty important. Without them, cities would literally not exist. It's people who are ultimately responsible for the way that places develop, be that through the planning laws they write or don't write, the buildings they architect, or the societies and communities they grow. But of course, this development is also impacted by a number of constraints, including environmental, financial, and political. Because of this, cities will never be perfect, and their development is likely to be driven by levels of compromise. Sound familiar? The city itself then becomes the entity, and the second key component, the environment, with which its population interacts. And of course, every person will have their own perspectives, their own perceptions, and generate their own unique and individual sense of place. When I was studying urban geography at university, the main course textbook was written by a guy called Michael Paccioni. And in it, he says that understanding the nature of the person-environment relationship is a quintessential geographical problem. Studies by urban geographers are important because of geography's concern with space. We like to map things. At a city level, research can be useful for identifying, for example, areas of deprivation within a city. That could do with some further insight. But it's at neighbourhood level where research can really start to make a difference by contributing to policies to help improve the quality of life for the people living in these areas. Quality of life is a hugely subjective term. There is no one definition nor definitive list of attributes that may contribute to it. However, Paccioni argues that there are two fundamental factors that contribute to quality of life within a city: urban environmental quality and urban livability. In other words, what's there, the environment, and how we, the people, interact with and feel about it. Urban environmental quality is derived from objective indicators, statistical data such as employment rates, crime incidences, and the number of education and sports facilities. It's an absolute term, an attribute of the environment, based on the physical attributes of a city, what Paccioni describes as the city on the ground. By contrast, urban livability is derived from subjective indicators, people's perceptions about aspects such as employment opportunities, fear of crime, and feelings about the quality of sports and education provision. It's a relative term, specific to the time, place, purpose, and values of the person making the assessment. It's based on the interaction between person and environment characteristics, and is an internal feeling, what Paccioni describes as the city in the mind. Both the environmental quality of a city and its livability are important for determining the overall quality of life for the people living there. And the exact same thing is true for our code bases. Michael Feather's 2004 book, Working Effectively with Legacy Code, is now nearly 20 years old. And despite showing its age in some ways, in others it's still extremely relevant. Like here, where he's reminding us that code is our house and we have to live there. Livable code was the subject of a talk by software architect Sarah May a few years ago, in which she compared the code we write to the interior design of our houses. May argued that there exists a scale of livability. At one end, a hoarder's house, or a complete mess of a code base. And at the other end, a set-dressed, beautifully tidy house with space-saving furniture and everything put neatly away in its place. Or a completely abstracted code base. Being honest, I suspect it's likely that the majority of us at least would not prefer to live at either end of this scale. More likely, there will be an optimum level of livability for your own individual teams. And Sarah May concluded her talk with this: the most important part of software development is not the code or the people. It is the system. And it's this word that seems to keep coming up. Ellen Ullman compared computer systems with cities. Geographers study the city as a system. And now Sarah May concludes that the most important part of software development is the system. There must be something to this. Referring to my geography textbooks again, a system is defined as a group of elements such that each one is in some way interdependent, either directly or indirectly, with every other element. So, it's the interactions between the elements that creates the system. And when studying the city as a system, geographers have highlighted the importance of understanding the interaction between person and environment when it comes to determining the quality of life for the people living there. So, what can we learn from this approach when it comes to determining the quality of life for all of us living in our virtual environments, our code bases? Well, perhaps we can take a similar approach to that of urban geography, in thinking not only about the environmental quality of our code bases, but also their livability. There are tools aplenty out there to help us assess the environmental quality of our code bases. Analysis tools that will count the number of lines of code, analyze function complexity, static analysis tools, and code coverage metrics. These are objective and absolute indicators. Perhaps not quite the code on the ground, but maybe the code in the cloud? But of course, these numbers will paint only half the picture. To complete it, we also need to consider subjective information about the livability of our code bases, from the people that live there, ourselves and our teams. How does every person on our team feel about the code base? What perceptions do they hold of different areas or aspects of it? What is the state of the code in the mind? Does this tally with our environmental quality metrics? If not, why not? When geographers are investigating urban environmental quality or livability within a city, they'll often refer to common lists of life concerns, things that we all care about on a day-to-day basis. Things like health, education, employment, housing, and so on. But what would a list of life concerns look like from the perspective of a developer living, as we do, in a code base? Well, our objective analysis tools will give us a bit of a head start in making a list, but there must be more that we can add. And being the geographer that I am, I of course created a questionnaire, well, Google form, to ask the team of engineers that I work with for their input on this. And as anyone who's ever studied geography will know, when assessing or analysing things, we always like to approach from the three perspectives of environmental, social, and economic. So without further ado, it's time to reveal the list of developer code-based life concerns that my very quick, very small sample survey produced. I started by asking about the environmental aspect. Now, for us, this is the code itself. So I asked, what about the code can make your life better when working with it? I'm sure you'll associate with some of these responses and no doubt have others that you would also add. Consistency and simplicity are key themes here. Basically, anything that reduces the cognitive load and environmental stressors. Next, I asked about the social perspective. Now, for us, this is our teams. So I asked, what about your team can help make your life better when working with the code? Again, I'm sure there are things here that you'll associate with. Collaboration is a key theme here, as is trust and support. Next, I asked about the economic aspect. Now, for us, this is the business influence. So I asked, what about how a business operates can help make your life better when working with the code? Now, of course, working with the business is also about collaboration and trust. But also highlighted here, I think, are aspects of the business understanding of us in terms of what we're doing, and our understanding of the business in terms of a shared vision. Finally, I asked, what other aspects contribute to making your life better when working with code? I think a couple of things are worth pointing out here. First, tools and documentation are important when working with code. And secondly, that notion of challenge and experimentation, I believe, highlights the desire I suspect we all share for that intrinsic motivation, generated by autonomy, mastery, and purpose, that freedom to experiment, as written about by American author Daniel Pink in his book, Drive. Putting it all together then, and we start to have a list of developer code-based life concerns. Things that contribute to our quality of life within our virtual environments. And one thing I think is worth highlighting straight away is how many of these things have nothing to do with the state of the code itself. And what we have here, I believe, is a wider picture, is a list of some of the key interactions between the elements in the system that is software development. So, what can we do with this list? Well, much like geographers may use a list of life concerns to investigate resident quality of life within a city or specific neighbourhood, so can we use this list of life concerns to investigate quality of life for developers living in their respective code bases. Results may tell us that there's a need to improve our onboarding service or process, or perhaps there's a need to improve the documentation of a specific feature set. Or maybe there's a need to educate the wider business on the importance of automating our processes. This insight will allow us to create personal goals, team agreements, and policies for our technical roadmap. Actionable strategies that we can implement to help improve our overall quality of life. When I started working on this talk, I was mainly concerned with identifying metaphors, similarities between city features and what we see in the code. But as I reconnected with that dormant geographer that lives within me, I realised that there are genuinely insights from the field of geography and its research methods that can help contribute to our understanding of ourselves and our interactions with our virtual environments. Geographic research continues to be of significance in real-world cities because of its ability to contribute to and influence future city policies that are implemented by urban planners. In this respect, urban planners are somewhat of our real-world counterparts. They hold a lot of responsibility when it comes to deciding how places develop. So I wondered whether there was any type of oath or mantra for urban planners. It's not official, but I found this and thought it was worth sharing because I believe it holds true for us too. Once again highlighting the parallels that exist between our worlds. It's quite poetic and more extensive than this, but pulls out the following 3 key points. I honour the wisdom of those who came before me. With humility I stand on which they have built. For me, this tallies with the retrospective Prime Directive. We truly believe that everyone did the best job they could with what they had at the time. I serve those who live here today. Their actions shape my actions. My vision must dance with theirs. I told you it was poetic. As developers, we serve our teams, and that team must share a vision, be that on approaches to ensuring quality of life, or with the business or sharing a shared vision with the wider business and product teams. We work for those who come tomorrow. May we deserve their admiration and inspire the best within them. We are but custodians of the code. Whilst we work on it, it's under our care. And it's our responsibility to ensure we do everything we can to achieve and maintain that quality of life that we strive for. Not just for ourselves and our teams today, but for our future selves and our future team members. And I hope this conference gives you the tools and inspiration to do just that. Just as all those rainy geography field trips allowed us the opportunity to explore the real world outside of the classroom, take this opportunity to be inspired, gain new insight, and make new connections. For you are currently on the largest dedicated PHP field trip in Europe. Thank you.
Thank you, Naomi. Great start to the day. So just a couple of quick reminders before we break and then start our main talks for the day. So you've got Freak, as I said, is not going to be here. So you've got Ian. And then a quick explanation as well on Karen's tutorial. That is a longer session, so it's a double length session if you want to go to that one. Otherwise, we'll see you again just short of half an hour. Thank you. Thank you.
All right. So, yeah, I am neither Freek van der Herten nor am I one of the presenters at the other two tracks, whether that's APIs or blogging. However, if you want to find out about what dependency injection is, what dependency injection containers do, etc., then you're at the right place. I am Ian Littman. Socials are on screen there. You can also follow along with these slides. I actually have a fair number of links in here for additional information if you want to dive deeper. Those are peppered throughout the slides. They are highlighted. You can, again, follow along using the link on screen. There's also a little bit of code in here that is, there's a GitHub gist on that as well. And my socials are up there, whether you are on Twitter or have run away screaming. So, with that, credit for the kind of original idea behind this talk goes to one Jeff Caruth. Back in 2015, he did this presentation and then proceeded to, for some reason, not speak as much at conferences anymore. So I decided to kind of pick up the mantle because these are pretty important design pattern conversations, and understanding how to use dependency injection and dependency injection containers, etc., allows you to, as Naomi was saying in her keynote, build maybe a little bit better of a city in software terms. So we'll actually be covering a lot of ground here, so it's nice that I have a little bit longer slot. We'll go over what types of dependencies you would have in your code base, what exactly is a dependency, and then look at actually injecting those dependencies rather than whichever way you have them declared right now. There are a few different ways of doing that. We'll go through them, refactor some code toward dependency injection, and then get into dependency injection containers with a few examples of how you would use those in practice. Now, we're going to be using kind of generic DI container examples that are not tied to a given framework, because if you're using a specific framework, then I assume you're going to use the container built into it. Now, highly coupled code as defined, where you're relying on specific implementations of specific methods to do exactly what you want. That's not great for maintainability. That's not great for understanding at a glance what your code actually does. Flip side of that is sometimes you're going to need to call another class or somebody else's code in order to do what you need to do. So you need to couple your code somehow. You want to couple it responsibly. Decoupled code, or loosely coupled code, is the idea there is that you have less in your head at one time when it comes to either building something out for the first time or debugging something when it goes wrong. Rather than having to trace through and say, well, this class depends on 6 others, which depend on 5 others, which depend, etc., and you wind up in a huge rabbit hole. Instead, you can look at one class, say, okay, well, I can focus on what this particular class does, what this particular code does, and take things a step at a time. And not worry about, okay, is the email handler actually doing something correct here when the piece of code that you're looking for or looking at shouldn't be interacting with the email handler directly at all. To that same end, if you are trying to test code in the absence of building your entire stack and trying to hold things more constant, then having loosely coupled dependencies allows you to do that. Say, okay, all else equal, let's see what happens when I test with this scenario or this one or another. So with that, let's talk about what a dependency is. Well, it's just a thing that you need in your code or in your application that's external to that particular piece of code or that application to get what you need to get done. Now, there are a few different levels of dependencies. What we're going to talk about today is at the class level. You can also look at the package or library level. That's what Composer Composer is for, and at the operating system level, which is what your OS package manager, APK, or brew, or apt, or yum, or DNF is for. Yeah, we're not going to talk about those today. That is a whole other discussion. We're just going to be looking at the class level. So we'll go through here a few different types of dependencies that either it's like, okay, yes, that's obvious. Yes, my code depends on a database, or my code depends on a caching system that's backed by maybe in-memory or Redis or Memcache or Amazon's white label versions of those. And it's okay, that's easy enough to realize that, yes, my code depends on those things. I should be potentially able to swap them out and not really care about whether the implementation lives on the cloud or on somebody else's computer. Oh, wait. But you go further down this list, it's like, okay, well, we have, say, a templating system. That's another dependency of maybe your controller. Maybe you're using Twig, or maybe you're using something that does like pure PHP templating. Or maybe you need something to build PDFs, or maybe you're saving to a file system, either locally or S3, or something that looks like S3 or something that doesn't look like S3. If something doesn't look like S3, then a abstraction layer like Fly system is useful there, and sometimes even when it does look like S3. For notifications, whether you're sending that via email or using somebody like our wonderful sponsor Vonage for SMS or push notifications or something to that effect. Maybe you throw something onto a queue. That's another dependency, whether that queue is something like SQS, Redis, RabbitMQ. In addition, any APIs that you may call, whether that is something like payment processing, or whether that is one of the 300 plus AWS services that are now out there. And finally, one of your more obvious dependencies is logging, because you're probably not just calling error underscore log everywhere, and likely not calling echo everywhere. Here are a few dependencies that may be a little bit less obvious. So the current web request, now as you get into modern frameworks, it's a little bit more obvious that the request passes through the application rather than just like, oh yeah, just pull from superglobals and we're good. Environment variables are dependencies on from your application. So if you have, for example, production mode versus dev mode, say if you're running a Laravel app or something like that, that environment variable is going to change how your application behaves, and it's it's external to your application. Your application depends on it. It's a dependency. The current user, along with permissions and session information on that user, will change how your application behaves. And if that user happens to have 4 names to it, or has admin rights or something to that effect, well, the application behavior will change based on that dependency. A few other things that I've personally gotten tripped up before is the current time. Now, maybe that's you're just using that as some abstract timestamp, but if you're doing any sort of math on it, you're doing any sort of checks on it, then your application may depend on what time it is, or maybe what time zone. So that is another dependency that there was a case I was working at a delivery company in the US, and we rolled out something and then it failed on a Sunday morning because something about PHP date formatting was a bug that I had introduced into the system, and that was kind of learn the hard way that the time that it currently is a dependency, and you need to realize that and try and loosely couple to that, or at least be able to, as we'll see later, pretend that it is a different time rather than just newing up datetime or datetime immutable and wondering what happens. Static method calls. Yes, they don't require instantiating a class per se, but they are pulling from some state that may or may not be global. Maybe it's just a helper function that takes inputs and produces outputs. But that's not necessarily the case, and you are depending on some other class, and that class may or may not be stateful based on what that method does under the hood. So you have to keep that in mind. And finally, sources of randomness. Now, you'll notice that this is highlighted here because as of PHP 8.2, there's the random extension that allows you to specify a source of randomness or even create your own source of randomness. Like, don't do that in a cryptographically secure context, but if you're building something for mocking out and testing out things, then it may be useful to have a predictable set of random information so that you can properly test things and get the same results each time and potentially test edge cases. So, little coding exercise here. We have, I believe, 4 dependencies in this block of code that does a little bit of order processing. And let's go ahead and highlight them. So first off, we've got the MySQL order repository there. We're just newing it up. We don't understand how the database credentials are coming from thin air, but they're there somehow. Maybe that uses MySQLi, maybe that uses PDO. We don't really care. But there's a hard dependency on the MySQL order repository. You can't override that yet. We're also using a logger. Show of hands, who actually has seen that global keyword somewhere? Okay. Maybe you've seen this or this. So there are a few ways of calling something globally or pulling a singleton instance in or something to that effect. And either way, it's an external dependency on a logger. Now, this may have a proper return type hint or return type declaration so that you know that you're getting a logger in here, but it does mean that there's a hard dependency on that method being implemented elsewhere, that class being implemented elsewhere, and in order to get logging into here. So we also depend on the current time by newing up a datetime immutable here. And finally, we have a static method call to our mailer to send the receipt out. So you look at this code and it's like, okay, well, what all do I need in order to make this class work? And it turns out we need an order repository, the current time, a logger, and a mailer, but we had to read through the entire code from top to bottom to figure out that that was the case. Additionally, if we wanted to figure out what all the mailer was being used for, given that it is it has some static methods on it, we would just kind of need to do a usage search for every single public method call in public static method call in the code base, rather than saying, well, any time that this dependency is in a constructor, then we know that, but other than that, who knows? So, and if we needed to change that mailer out, for example, logging rather than mailing, then hopefully the mailer has something built into it that allows us to do that, because the language isn't going to give us any help there. So allow me to explain a potentially better way, which is dependency injection, where instead of a class calling out to what it thinks was probably the location of a logger or a mailer or an order repository, instead, those items get injected, get pushed into the class, and something else is in control of that, potentially your test framework, potentially your standard framework. And at that point, it effectively inverts what the dependency graph looks like. So instead of saying, okay, well, I'll grab these classes as I need them, everything is set up in advance, or as we'll see later, potentially not quite as in advance. And we kind of, at that point, know what we need in order for the class to do what it needs to do. Now, this is different than the dependency inversion principle in Solid, in the object-oriented programming principles. It is related. It allows for easier application of the dependency inversion principle, but dependency injection and the dependency inversion principle are not the same thing. So we'll go over here 3 different types of dependency injection: constructor, setter, and property. So for constructor injection, well, you new up the class, and instead of asking for a logger halfway through, you provide it when the class is instantiated. And that's just the constructor there. Now, as of PHP 8.0, there is a little bit more syntactically sugary way of doing this that saves a line of code, which is this. It's called constructor property promotion. This and this are equivalent. It's saying, hey, I have this private property of logger, type logger, and oh, by the way, when somebody passes it into the constructor, just go ahead and assign it, and don't worry about it. I will be using that a fair amount later in this presentation. So if you're on PHP 7.4 or below, number 1, please upgrade, and number 2, unfortunately, you will not be able to use this. So the cool thing about constructor injection is that if you do that for every dependency, then there's one place you need to look to figure out what a class depends on. And when that list gets a little bit longer, you realize, oh, well, I need to maybe refactor this class because it depends on way too many things. And those things may be only used in a method or two, but it's a long list. Let's make this easier to think about. Let's make this easier to test. Let's shave that down, maybe split the classes out. And you can't, if you constructor inject, and that's the only way of providing these dependencies, then they're not going to move out from under you during the life cycle of the class. Unless you set them internally or do something interesting like that, but otherwise they won't move out from under you. And if you want to prevent things from being set internally, you can use the read-only keyword on the properties as of PHP 8.1, or just call the entire class read-only as of PHP 8.2. Now, the issue here is that if you are refactoring an existing class that has a whole lot of dependencies, then you might wind up with something like this. This is code that I wrote in a controller in authentication application, and yes, we needed all of these dependencies. It was kind of a mess, but this gets a little bit unwieldy, overwhelming, etc. At least we know that we need all those, but it may get a little bit confusing. And also, you may need to add a dependency in later in the life cycle of the class. Now, there's something to be said for mutability of the class not changing over time. That's a whole different discussion. But if you need to be able to swap dependencies during the execution of the life cycle of that class, constructor injection is not really going to help you with that. Additionally, if you have a lot of methods, each of which uses maybe 1 or 2 unique dependencies, then you may be setting up a whole bunch of class infrastructure that you don't necessarily need. So, in response to, oh, well, we have this big list of dependencies, oh, I know what we'll do. We'll pass an array of options into the constructor, and then we'll pick those out, maybe test for types, and maybe, please don't do that. It's going to come back to bite you later on. It makes your code less easy to reason about. It doesn't give you that type signature validation that that proper constructor injection would do, and like your IDE is going to complain at you and not know how to autocomplete, et cetera, et cetera, et cetera. If you have optional dependencies in the constructor, then PHP 8.0 allows named parameters. So that will give you something similar looking to an options array. except without the array notation and with proper type checking on each of those values. So definitely do that instead. So next up, we have setter injection. So we may not need a dependency in the constructor, maybe we need it later, and we can just go ahead and add that by still declaring the property on the class, but then having a set method of, for example, set logger, and then calling that method from wherever a logger is already defined and needs to be passed into the class. Alternately, you have property injection, and here you have public properties on the class, and you just assign something to them. Now, this is a little bit safer now as of PHP 7.4 because you can type those properties so that if somebody is randomly assigning a string to logger, then things will fail rather than silently succeeding, and then you have a method call on a non-object later, and then your program fatals in a weird way. The thing with this setup is, unlike in the previous cases where you could use a read-only property to say, okay, even if we do setter injection, this is only going to be set once and then no more. In this case, setter injection, well, read-only properties are only settable within the context of a class. You can't just go out from outside the class and set a read-only property, which is good, but it means that you can't use them in this particular setting to make sure that that a dependency is only set once during the lifecycle of the class. So it's something to keep in mind. So the nice thing about setter and property injection is that if you have a dependency that takes a fair amount of effort to build in terms of compute or network or whatever, then you can delay that setup a little bit longer. And if you don't need that particular class a lot of the time, then you can just avoid setting it at all, which, again, may be useful depending on how your code base looks currently. And you know, that's all well and good. The catch with this is now you have to check. Anytime you potentially use that dependency, you need to check to see whether it exists and bail out if it doesn't. You have a whole lot fewer guarantees with setter injection or property injection than constructor injection because the class can be completely valid, completely built without that dependency. So it's useful to explicitly show in your class that the default value of, say, a logger interface or whatever that's that setter injected is by default null, so you know to check for that anywhere that dependency is used. So to give you an idea of what that looks like in order to actually safely handle this, you have, in this case, a logger dependency in this code. And if it's a property injected with no type checking around it, then every time you want to use that logger, you would need to check to see, hey, does this exist? And is this of the type that I expect it to be? Because if not, then I'm going to get a method call on maybe a method that doesn't exist, or maybe on a non-object, and it's just a mess, and your code fatals, and it's a problem. So you would have to have these guards on every time you use that dependency. Now, if you had the property declared as a specific type, you can just do a truthiness check, in which case it makes it a little bit cleaner, but you're still calling conditionals every time you want to use that dependency inside your class. Here's an alternative. Use constructor injection, but if a dependency is optional, have the ability to pass in what they call a null object pattern. In this case, a null logger that says, hey, I have these methods. You can call them. They're not going to do anything, but you can go ahead and call these methods. Don't worry that the implementation does nothing. You pass that in the constructor, and now your code is significantly cleaner in the class because it doesn't need to care whether that dependency exists or not. Now, null logger is a interesting example because that's actually built into the PSR log spec. So just use their implementation rather than building one of your own. And if you really want to say, hey, I don't want to pass this dependency all the time, then as of PHP 8.1, you can have defaults that are constructed objects inside your constructor definition, like we are doing here. Again, 8.1 or above only. This is why you upgrade to newer versions of PHP, is these quality of life improvements. So one interesting thing you can do with setter injection is you can use a combination of traits and interfaces to tell your dependency injection container, which we'll get into later, hey, any classes that implement this interface, go ahead and call this setter on them, which may reduce the amount of code that you need to write to wire up dependency injection. And the way you do that is you follow these steps of you set up a setter in the trait, you set up an interface with the same signature, and then import the trait, as well as telling it that it implements the interface, and then tell your container or equivalent, hey, if you see this interface, call this method on it, call this setter. This pattern is actually built into the PSR logging spec as the logger aware interface. So you implement the interface as well as the logger aware trait, which has that logger setter as well as the logger property. Now, unfortunately, you can't implement an interface on a trait. There's an RFC for that. That has gone absolutely nowhere. That RFC is linked at the bottom of this slide. So there's one final type of injection here, and that's parameter injection. And so if you're using a framework that has a controller or action route that takes a request and maybe a response and some other items in those parameters, you are already using dependency injection in some smaller way. The example I have here is actually a Slim framework route callable. It's taking a request, a response, and route arguments as parameters, and then returning a response therefrom. And sometimes that request and response is enough to do everything you need to do. In some cases, you may need database access or whatever to pull additional information. But this is parameter injection, and so is this for folks who want to see an example that's more Laravel-ish. Yes, Laravel has parameter injection both on its controller routes as well as in its commands. So this tightly scoped parameter injection means that you're not worrying about like, okay, well, I have 10 dependencies, but 9 of those are only used in a method or two out of 10 methods in the class. You don't have to worry about that because the parameters are provided directly to that method as local variables, not as properties. And that's great for keeping a tight lid on exactly what your code needs. The con of this is that you have to spend the effort to get those parameters where they're needed and then pass them into that function call. And getting the parameters where they're needed tends to be the hard part because it's like, well, you have to get them from somewhere, and potentially you may not have access to those. With that said, if you are, for example, using the Laravel framework and you've got a route callable or a command invoke method, then the framework will inject those dependencies for you as best as it can tell what they were supposed to be. So it's doing that heavy lifting. And that's particularly important in the Laravel command side of things because the way Artisan works is it's going to construct every single one of those commands, which means that constructor injection is actually rather heavy in that context. So you actually want to inject things as late in the life cycle as possible. So you can mix and match these as needed. In a standard framework, you're going to have potentially service classes that are constructor injected. Maybe you're using that logger aware trait, so you're having to write less a dependency injection wiring code. And then on your route callables, you're injecting a request and potentially a response or a response builder. So there's no one single way that you want to write every single line of code in your application. There's no single best answer for like just use constructor injection all the time. It will vary. What I've tended to do is a lot of constructor injection, a fair amount of parameter injection, and just leaving it at that. But your mileage will vary depending on what your code base looks like. So, mentioned in a slide earlier that we would talk about dependency inversion principle. That principle is that you depend on abstractions, not on low-level details. You're either producing those abstractions or you're consuming those abstractions. You're building small, generic interfaces and then using those interfaces to provide functionality rather than relying on the fact that, for example, your way that your users are stored is in MySQL or something to that effect. Just double checking how we are on time. Okay. So kind of a tip on this is you can take small interfaces and then build successively larger interface footprints on that. You can do that either on the interface definition side, because interfaces do support multiple inheritance. You can say interface A extends interfaces B and C, and the functionality will be a superset of B and C for any class that implements A. And now with PHP 8.1, you can use intersection types to say that a class has to either be a concrete instance of A or an implementation of interface A, and also interface B. So you can build that, hey, I need both of these, or all three of these, or all four of these specifications when you are building your function signature. And you can do that either on, again, the interface side or as you are speccing what you want. PHP 8.2 extends that. If you were in the talk yesterday about PHP types, among all of the ranting, you saw the disjunctive normal form of types on how you can build out requesting exactly the type that's needed without having to modify your underlying class code. So there's a kind of semantic argument of, okay, well, do I want interface in my interface name, or do I want just the interface to be whatever it is and then the implementation classes to look different? Doesn't particularly matter, just please be consistent about it. In this case, as long as you're consistent within your own code base of, this implements SMS provider or this implements SMS provider interface, and then your implementation classes may or may not need to change names to avoid conflicting with that. It's really your choice. So, abstractions should not leak details. In a particular implementation should conform to whatever interfaces it provides, and PHP will tell you if you either subclass something or you implement an interface, and at least from the type side, whether if you are more picky about arguments that you accept for a function call, or are not providing as strong of a guarantee on what you return. That is idea of covariance or contravariance, and there's an article in and of itself on that, and well, there's that in the PHP manual. You can dig into that in further detail later. But in this case, yeah, the return type, let's say the interface actually specifies a void return type. We're good to go here. There are no parameters. There's void return. The interface exposes forces a return type of acceleration, which maybe that interface specifies, okay, what direction am I accelerating in, what speed am I accelerating at, and what units that speed is in, or maybe the speed is a value object that has units and magnitude in it. Either way, as long as both Vroom and Zoom implement acceleration, then everything holds. You implement the interfaces. Don't rely on specific implementation details there, but whether your vehicle runs on electricity or petrol, you still get that acceleration out when you press the accelerator. So for a more realistic example of something that you would see in your own code base, if you decided to switch the location that your users were being pulled from, maybe you're not going to switch from MySQL to Redis or a gRPC microservice, but you might say, well, my user repo sometimes pulls things from, say, GitHub SSO or Facebook or Google or maybe Twitter if they don't deprecate that API. And each of those, maybe a different user repository, or maybe different branches in the same method of a user repository. But each one of those should return something that conforms to the user interface, or maybe returns null. In this case, we have a nullable return. We're not throwing exceptions if the user isn't found. That's a whole other discussion. But in this case, the user might have on its interface that it has a name with first, middle, last, and ignoring that people may not have all of those names or may have more of them. They may have a unique ID. They will have an email address or something to that effect. And every single user, the thing that you'll be able to rely on is that those methods exist, because every single one of them implements the user interface, no matter where they come from. And no matter whether that call to get the user's email pulls a property from that user or fetches that information lazily from some external service. So, going back to our example earlier where we had various ways of showing the global logger, let's actually start refactoring some stuff here. So, first off, we will take care of the first two dependencies, the MySQL order repository and the logger. So those are pretty easy. We pull them into the constructor. And now, while we're doing that, because we want to depend on abstractions rather than concrete classes, we're saying, you know what, MySQL order repository, let's make sure that that implements order repository. We're not using the interface in the name of the interface here. It's like, okay, well, we're being passed an order repository. We don't care what it's backed by. It could be MySQL, could be MongoDB, could be IP over carrier pigeon. And so now we've got that. We're passing it into the constructor. It is now no longer the problem of this class to figure out what repository to use and what type of repository. As long as it satisfies that interface, we're good to go. In addition, we've pulled the logger into the constructor. We'd probably use a logger interface here, but this is not PSR3 compliant, so for the sake of showing what's going on, we're using a concrete logger here, and that's fine. And the other piece of the refactor that we did here was, since that logger was a local variable before and it is now a property, we had to change that logger call in the actual method that does things. So let's move on and extract a couple more dependencies. Let's extract the current time and the mailer. So this does we assume that we've done a change to the mailer as well, so that that is a class method rather than a static method. But if we do that, now all 4 of our dependencies are constructor injected. So if we want to, for example, swap in some stub at any of these cases, or some mock, or what have you, we absolutely can. Now, this is pretty good, but let's make one final tweak here, because if this class stays around, let's say we're running this at a command line interface, we want orders to flow through this service rather than having to build an order service each time. And now that time is a constructor injected dependency, that makes it a whole lot harder. We would have to build this order service each time because the time wouldn't change. So instead of constructor injecting that, let's move it down to a parameter of our complete order function. Now, this requires now that we push a time into it. Now, in the caller, we can just say new date time immutable, current time, that's fine, but we don't wind up with an issue where it's like, yeah, it defaulted the current time and we found an edge case because we did some date math and we're closed on Sundays or something. So at this point, it seems like we have the dependencies in the proper place. And this makes things a little bit easier to test. And it's very clear when we are using something external to the class. The final thing here, because I assume I'm running on PHP 8.2 or at least PHP 8.0, is we're going to use constructor property promotion here and declare those properties. Now, in the previous slides, I assumed that I had properties declared, snipped out of this view. And now those 3 lines that I wasn't showing don't need to exist anymore because they are actually declared by constructor property promotion. If I wasn't declaring those lines, then as of PHP 8.2, I would be getting warnings saying that you're declaring properties dynamically, please stop. So, with all that said, we have this magical dependency injection container that we've been using to constructor inject these things, or at least we've been assuming we can use to build this order service out. So dependency injection container is just a place that wires up all these dependency relationships now that we need to push dependencies into constructors as the classes are created. And the end result of that dependency injection container is saying, okay, hey, I need a particular implementation of this class. The dependency injection container will figure out, or was told by you manually, how to build that class. It'll say, okay, either here's an instance of that class that's built from scratch, or hey, we already have this class built, here's the instance that already exists. So you're not using a bunch of extra memory and CPU cycles to new up something that is already there. Now, I would say a lot of the use of the new keyword will be in your DI container, or under the hood, or in configuration of that container. But not all of it. If you're building out value objects, or if you have a factory class that it has some of its dependencies and then is parameter injected more, and then it builds classes from there, you can still use the new keyword somewhere else. You don't have to inject absolutely everything. So there are going to be places that you use the new keyword outside DI config. You do not need a dependency injection container to do dependency injection. You can do that manually. It just may take a little bit more work and maybe spread a little bit more over your code base. It really depends. Also, dependency injection containers, basically every single one of them has this big warning: do not use me as a service locator, because that takes the guarantees of constructor injection or setter injection around type safety and that sort of thing, and then just throws them out the window, because you're saying, hey, I want my entire application, I'm going to refer to something by a string identifier and give me that thing back out and hope it works. It winds up hiding what your dependencies are rather than making them more explicit if you use it the wrong way. For example, this way. Hey, look, we're constructor injecting a container interface. What does that container interface guarantee? Well, it guarantees that it has a has and get method, and those methods take a string as a parameter, and then you get something or an exception out on get, or a Boolean on has. Of course, we are assuming that all of these dependencies exist, so we're not going to call the has method, we're just going to call the get method and assign properties. And yeah, that means that you now don't see what this class actually depends on. All you see is like, it's a container configured some way, we don't know what. You now, like, we're lucky here because you're looking at a constructor and it's like, okay, well, it's these things. And maybe the properties on the class are typed so you understand somewhat what's going on, but this is not how to use a container. Nor is this how to use a container, where you just inject the entire container into the class and then pull dependencies out on a whim. Yes, you may need to do this in a factory case or something to that effect, but the use cases where this is the right way to do things are quite limited. So dependency injection containers on the face of it are pretty simple, at least for a trivial implementation like this one. In this case, we use magic methods to both get dependencies and set them. And the way we pull dependencies out is we assume that we've been given a callable that, given the rest of the container, and this is again the only place where you want to be passing the container around as a parameter, given the rest of the container, new up a class with parameters from that container, or new up the class with no parameters if that class has no dependencies. And eventually, you'll wind up with a class with either no dependencies or maybe a dependency on some environment variables. And the execution of this will wind up calling callables, pulling dependencies out of the container until you have the fully formed object that you asked for. Now, this is back when Twitter had 140 characters. This was built by Fabien Potencier. I had to switch the link on this slide to archive.org because the website has since ceased to exist, but that does work now as long as you don't weirdly get blocked because of age verification in the UK from archive.org. I don't get it. So the way you would use this is, let's say you have a class that needs a logger, and then you have a logger class. You would first use the magic setter to say, hey, my logger is a function that, the logger dependency is a function that returns that logger. And then whatever service is, to new that up, it needs the dependency that I've already stored at logger. Now you could declare these in multiple orders, in different orders, because these are lazy loaded. These are callables. They aren't building the classes right then and there. And this little snippet of code actually does work, and it will, if you ask for a needs a logger, or sorry, a my service, then it will give you that service back with a logger already built in as a dependency. So as a trivial case of, hey, how does a TI container work? You have one right there in 140 characters. Now, there's been some standardization around containers, and this usually gets used for dependency injection, but may be used elsewhere, of container interop, now PSR 11. It has a few extra methods on it. So when Twitter went from 140 characters to 280, we are going to completely ignore the disaster that is 2,000 character tweets. It's like, okay, well, let's see if I can build an extension of the container that we just showed, but this time with the container interop compatibility. And the answer is yes, we can. We just implement the interface and then add a couple more methods in there. Now, this isn't actually throwing all the necessary exceptions necessarily, and I believe the container interop PSR does have type hints on it. So this isn't quite right, but it does get you your has and get methods in case you want to use those rather than magic _get and _set. And because phpc.social exists on the Fediverse, Mastodon, etc., there is a post there, and I had so much room left over because this was this was either 280 characters or less that I, well, just kind of wasted those extra characters, but let's ignore that. So let's take everybody's favorite coding challenge and dependency inject it. The things that we will be injecting here is things that can be cast to a string. So if somebody wanted to do foo and bar rather than fizz and buzz, then they wouldn't need to revise our fizz buzz class. They could just revise the items at the top. So here are our classes, and we've got this invoke thing that, given a number, is going to either print out the number or print out some mix of fizz and buzz, or some mix of whatever fizz and buzz casts to as a string. So we're going to set up that container. We're going to use Twitty here. Set the fizz dependency, set the buzz dependency, set the fizz buzz dependency, and then call this in a loop. And in the case of, okay, we're using Twitty++ here because we actually have that get method that is PSR 11 compatible. And you know, that will keep on pulling new instances of those classes out of the container because this is a really trivial example. If we had a more beefy container implementation that might reuse those classes, effectively caching them. So again, this is a trivial example. You could use it in your code base, but there are a lot more featureful DI containers out there. If you have a semi-recent PHP framework that you're using, there's one built in, whether that's Symphonies or Zend or Laravel. I actually did a presentation walking through the Illuminate container back in 2019. That is linked here. But if you don't have a container that is already built in, then you can use one of these four down here, or there are plenty of others. And for the sake of time, we'll look at Pimple, and we'll leave off the other two. You can either look at slides or ask me later about those. So with Pimple, it's a bit more involved than 140 or 280 characters, which gives you additional functionality. You set things at array indexes, you ask for them back, or you use the PSR 11 interface to do that. You can set factories, which will give you a new instance every time. By default, it will give you the same instance once it's built one. You can protect a callable so that it doesn't actually call that callable if you're trying to use a single function or a closure as a dependency. You can also tell it, hey, that function that I passed in, I didn't protect it or anything, but just give me that function back out. Pimple will happily do that for you. You just have to call raw rather than its getter method. And this simple container was the default built in to Slim 3. And you can add it into Slim 4 because Slim 4 uses anything that's PSR11 capable. So if we looked here and said, okay, let's refactor this, we're newing up a repo and we're pulling PDO creds from somewhere. First thing we'll do is we'll actually pull the database into a container and new it up with environment variables there. The next thing we'll do is pull that repository into the container because, well, we have the database in there, might as well. And now the container is bound to the route callable here, so we can just call this get and get the service out. And then we go one more step, pull the entire thing into an action that's a class, constructor inject the service, and then say, you know what, now let's take that action class, throw it into the container, new it up with that service directly, and then tell the application to call, to pull the dependency out of the container and use parameter injection to invoke it with request and response. With that, again, for the sake of time, I'll cut this off now. There are slides on PHP DI, including information about auto wiring, reflection, etc., as well as league container. And feel free to take a look at this presentation after for those, and also feel free to catch me later on today for questions, provided that you hold any dependency injection questions while I am presenting on right here at 1:30 about Lambda, just so that the people showing up here for Lambda aren't ridiculously confused about why you're asking a dependency injection question. With that, this has been dependency injection for mere humans. I am Ian Littman. You can find me on socials and on GitHub at the links on screen. You can find the slides there as well as a gist with some of the code that was shown. And thank you for your time. This is it's been great.
Okay, does anyone have any questions for Ian? No, I think you're safe.
All right. If you do find that you have questions later, find me, ask me. I'll be around.
Right,
Thanks, everyone.
Thank you very much. Your next session starts in 15 minutes. or may not be questions at the end, depending on how we do for time. But other than that, I'm going to hand straight over to Kieran. Thank you.
Thank you. Hi, everyone. This is a big caveat because I'm never quite sure how things come across in conference brochures, but this is aimed at people who have either a very light understanding of Docker or have no idea at all. Hello, everyone. I'm Kieran. I'm involved in a bunch of open source projects like PHP Spec and Behat and Cucumber. I do a lot of coaching and training for teams in agile stuff, how to get better at delivering. I also do architecture and stuff. I work for a few companies. Half my time at the moment is spent with Rove. So if you want a group of experienced developers who know what they're doing to help you with a project, talk to me and I'll send you to the people who know how to do sales. I have ADHD, and I mention that because I got diagnosed as an adult, and a contributing thing was someone at a conference talking about it. So if you want to talk about that at the social or something, find me. What's Docker for? There's a sort of constant problem in software development of everything works great, all the tests pass, and then you deploy it to some other environment and everything breaks terribly. And I think that's been the case since the second computer was invented. And there are various strategies for dealing with it. Back in the day, we used to sort of have lots of tools that would set a server into a known state and sort of run them locally and hope that we're matching things up. An obvious way of doing this is a virtual machine. This is a VM I use to kind of sandbox a particular client's incredibly intrusive VM. But it's a pain because I'm running macOS and I'm running a virtual machine that's macOS, and it's using loads of resources because there's a VM kind of has complete isolation. The advantage of a VM is you can run a different operating system inside your operating system. But when you're running the same operating system, there's no efficiencies, there's no shared components. I've got to have a whole separate macOS install eating up my disk. The basic system components are running inside the VM and outside the VM, that kind of thing. So, going back 10 years, there's a lot of usage of VMs for local desktops, tools like Vagrant. People are still using them very efficiently. But there's a performance overhead, there's a resource usage overhead, and I've never been that happy with the various tools that people use to ship VMs around, and ship your VM to production always seemed a bit weird and bulky. So there's a sort of gap in the market for a better way. And what Docker's really about is, don't ignore the blob of text, but this idea of OS level virtualization, where if you're virtualizing an operating system inside an operating system, you can probably share a lot of stuff that already exists. And really, what Docker and containers do is they sort of don't virtualize at all. You run a process and you isolate it from the rest of the system, so you get a lot of the benefits of virtualization without this sort of clunky semi-emulation layer. A thing called C groups exists in Linux. You don't have to understand the image. But there's this idea that up here you can see you've got your real file system, and then certain processes can be run, isolated from the rest of the OS, and they see a file system that you kind of tailor to that C group. It's called a control group. That's a base building block in Linux. So a container isn't a VM. It's a Linux process that's running in an isolated way, and it's been given a file system. It's like Neo in the Matrix. He thinks he's in a city, but it's just all an illusion. That's kind of what your process is experiencing when it's running in a container. It thinks it's got access to the root of the disk. It thinks it can list all the other processes, and there's no one else there. But it's all a lie. And the rough timeline was C group stuff was worked on for a few years and merged into Linux. 15 years ago, Docker started as a startup around that time with the idea of building tools atop this, make it easy to share containers, that kind of thing. And to their credit, 2015, most of the specs of the sort of foundational technologies of Docker got opened. So now you can write your own Docker-like tool with a compatibility with the spec to run containers, make images, that kind of thing. And also, 5 years ago, Docker started a long process of chipping out components from their monolith into open reusable components. So you can write your own thing by implementing the specs, or you can use components that are off the shelf to build your own container runtime. I'm going to focus on all the Docker stuff, but just be aware there are lots of other projects that share varying amounts of code with Docker that do things differently. And it's all broadly compatible. So to get started, you need to install something. If you're a Linux user, you're probably going to have the fastest experience using Docker, and you just get it from your normal package manager. If you're on macOS or Windows, Docker Desktop is not a bad choice. There's lots of stuff where it will try to sell you extra services, but you just ignore it. And if you're on Windows, you can pretend to be a Linux user and apt install it in the Linux environment thing. So the problem here is I said it wasn't virtualization, but if you're a Mac or Windows user, you're using a virtual machine, but you're just using one virtual machine, and it's semi-hidden from you. So I'm running Docker Desktop for Mac. I never think about the VM, but there is one Linux VM being started, and all the containers are being run inside it, kind of in the background. And Windows Subsystem for Linux has a managed VM that it's using. WSLU2 has a managed VM that it's using. The architecture of Docker is pretty straightforward. We'll introduce a few concepts. So there's a service called Dockerd that's always running. And this is actually a criticism of Docker. You might not want to have a long-running service on your laptop just in case someone asks it to run a container. So some of the Docker alternatives are daemonless. But generally, there's a daemon running on a host machine that's going to do all the work. You have a client. So if I type Docker something, the binary then talks to the daemon and tells the daemon what it is I want to do. Most of the time, if you're a developer, these are the same machine, the client and the host, but conceptually they could be on different boxes. I could be running commands that are talking to a server somewhere else to tell it to run containers. Docker daemon maintains a store of images. Best way to think about an image at the moment is it's a file system. It's a snapshotted file system, something like a .iso file or a USB thumb drive, Plus it has some metadata to say when I run this image, what process should execute, which one process should execute. And there's this concept that images can be pushed from your host out to a registry, and you can pull them out from a registry so you can share images. So the image is it's kind of like a snapshotted disk. Let's think about it like that. The daemon is also responsible for managing running containers. So they're not VMs. I might say that too many times today. And don't even think of them like a sort of VM. A container is a process that's been given the files it needs to execute. So the image snapshot disk thing, when you run it, a process will run and it will become a container. And then the daemon is responsible for stopping, starting, creating containers. So here's how you run a container. If I type docker container run hello world, I get this message that hello world doesn't exist locally, and I'll see some sort of progress bar style downloading happening. And then hello world happens. The hello world script runs. So what's happened is I've asked to run hello world. The daemon's checked my image store and says I don't know what hello world is. It's pulled it from a registry. in this case the default Docker registry. And then it's launched a container based on that image. And that image is just a shell script that echoes hello world. Next time around, I won't see the pull mechanism. It will just say hello world. And like I said, on Linux, you will have native performance. This isn't a high performance, script. But it's just like running a process on Linux. On Mac and Windows, it's just like running a process in a VM. A note on the examples, when I show commands, I'm going to use the newer, sort of longer commands. The sort of namespace of the main Docker executable got a bit crammed. So all the things that are to do with containers can be prefixed with container. All the things that are to do with images can be prefixed with image, and so on. And if you ever want, a nice aspect of that is you can type something like Docker image help, and it will show you all the things you can do with an image, rather than looking at a big list of stuff. So I've tried to use the long forms of commands. Also, any flags I'm showing, I'm trying to show like the long format, but they nearly all have like a single letter thing. I just think that's bad for presentations. So I can list which containers are running, and there aren't any running. If I ask for all the containers, I actually see that my hello world script, the script ended after it outputted the string, but it's sitting in this kind of stopped state. I could start it again and it would echo the string again. For one-off scripts, that's not that useful to have them stopped, but for something like a web server, you might want to be able to run it for a bit and then stop it, and then sort of resume it, restart it. There's lots of detail you get here. The main thing I want to show is that containers have a unique ID. They also have a sort of generated friendly name, or you can set a name. And I quite often get people send me a screenshot because my surname is in the dictionary that's used to generate this. So you'll get like idiotic McNulty, and someone's like Harson, that's Kieran. And that's because someone added all these computer pioneers to the dictionary. I don't know if I'm related to this lady, but she apparently invented the subroutine. And you'll see lots of computer pioneer names in the list. So if I've got a stopped container, I can delete it. Remember, all of these things are going through the daemon. I'm asking the daemon to do it, and then the daemon's doing it. And then I can list, there's nothing there. And for a one-off run of something, you can add this RM flag, which means instead of stopping at the end of execution, the container will be completely deleted. So if you're running your PHP unit tests and you forget to put RM, your list of stopped containers will slowly grow. It's not a problem, but it will annoy you one day when you look at it and realize there's loads of junk. A gotcha when people are running interactive containers, and I think this comes from thinking about them as VMs, is they think, well, I'm going to run Ubuntu, and nothing happens. The reason is that when you think about starting Ubuntu, you sort of think about booting a desktop, and you think about millions of processes are going to start at the same time, and the scheduler is going to be responsible for time switching. The Ubuntu Docker image has the process that's been nominated to be run when you run Ubuntu is bash, and bash only. And bash doesn't like talking to non-human users, or at least it doesn't sit around waiting for input. If I add these flags to say, this is an interactive terminal, someone's typing, and also please, I'm cool with colors and stuff, it will launch a bash session in the container. But I want to emphasize that's because the Ubuntu image is configured to run bash as its main script, its entry point. So I can poke around this. It's like I'm logged into a Linux box now as root. And I can kind of poke around and look, and it looks like Ubuntu. And I would be forgiven for thinking that means lots of services are running. But if I PS, it's just me there. I'm the only one in there. The bash session that I ran is the only thing running. And it can subshell and run PS and stuff. But there isn't the normal stuff you would expect to be running if you did that on an Ubuntu box. but all the file systems there. It's a complete Ubuntu file system. The only way you can tell you're in a container, really, is if you look at the kernel, it's the same Linux kernel in every container. It's shared between them. So the difference between Ubuntu and Debian is just the file system. You've got the same Linux kernel version running. So how do you name a Docker image? They have what's called a reference, and they look a bit like a URL. I mean, I guess they are a URL. And they come in three parts. Firstly, an image knows which registry it belongs to, and this is a bit different to something like Git. In Git, you tag something and then you decide where you're going to push it to. With a Docker image reference, the name of its sort of home registry is built in. It knows where it lives. So if you want to push to two places, you kind of have to tag it with both names. There's an idea of a repository. That's basically the path to a logical grouping of images. You'll find in public registries, like the one Docker runs, like the one AWS runs, maybe not, like the one GitHub runs, they tend to have a two-element name. That's just to make user permissions easier for them, a bit like how if you run your own Git server, the paths can be as deep as you want, but if you're using GitHub, it's going to be organization, project name. You'll see a similar sort of thing. So that's just like the path to the image. And then there's a tag. A specific image gets tagged. Like with Git, there's a sort of expectation that if I look at two different tags, the images will be somehow related. But there's nothing stopping you pushing completely different images to the same repository with different tags, in the same way you could have random stuff in your GitHub branches that have no relationship to each other, right? And the tags tend to be some sort of semantic versioning type format, but that's up to the maintainer. Now, before when I ran Hello World, I didn't have that big long string. I just had Hello World. So there is some defaulting, and this is Docker specific. So in the Docker tools, if you don't mention the registry, it looks at Docker Hub. So it's a very mild kind of vendor lock-in thing. Although Docker Hub has started charging you to go over the certain rate limit, which is a bit annoying. The repository if it's a single element name, the repository gets prefixed with library. Library is an organization on Docker Hub owned by Docker. And the default tag is latest. Latest just means the user didn't specify a tag. And it's just a default value. And you can see this. If I pull node, it tells me it's downloading Docker.io library node latest. I can explicitly pull the long version. It's the same thing as far as the tooling is concerned. So lots of registries exist. You might, if you've got an open source project, GitHub's container registry has quite decent limits on how many packages you're allowed to host for free. Amazon has a container registry. So if you're big on AWS, you'll probably be pushing your images into that. Or, one of my projects, we use GitLab, hosted GitLab, and that has a registry. So the CI server has it. Something to watch out for if you're, analogizing it to Git. In Git, we have a concept that branches point to different hashes over time, and tags always point to the same hash unless the maintainer's been naughty and retagged stuff. But in Docker land, images, you expect the tags to be retagged regularly, and so don't be surprised when that happens. So I looked, this is a few weeks ago, at PHP, the library PHP image, and you'll see that the latest version was 8.2.1 of PHP, and also the tag latest pointed to the same image. 8.2 pointed to the same image, and 8 pointed to the same image. The idea is if I'm saying PHP 8, and a new version comes out. I think we're now up to 8.2.3 a few days ago. So if I look now, latest would be pointing to a different image. 8.2.1 would still point to the same image. And if I've specified PHP 8, I'll always, every time I pull, I'll get the latest PHP 8 image. So you have to be aware of stale tags. I constantly see people say, please run the latest PHP, and they're surprised it's an old PHP. It's because they're running the thing that was tagged as latest last time they pulled. It's like, I'm going to keep mentioning Git. It's like if you check out master on Git without fetching, you'll get the state that master was in last time you checked the repository, if you see what I mean. There's no magic. There are flags you can add to make it check. But I think the word latest makes people think there's going to be some mechanism that is ensuring it's latest, and there's no such mechanism. So if I pull, it'll actually say, oh yeah, I've got a new PHP latest now, and next time I run it, it's a newer version of PHP. And there's various ways of looking at what images you've got, and if you want to image inspect an image, you get a huge amount of JSON come back that tells you all about it and how it got built and what's in it and who made it and that sort of thing. So let's build one. Most of the time you'll be building an image for your project. And the way you build an image is in Docker, is writing a Docker file. So the builder, which is called BuildKit, for the last 6 years it's been BuildKit, and it's slowly become the default builder. I ask it to build, and it looks for a Docker file that looks like this, and it turns that into an image. Oops. So the first line, it tells me I want all the layers from this public image. I want to start my image based on this public image, and then I want to copy a script into the image, and then I want to configure it so that script is the thing that runs when the container gets started. Like I override what the default script is. And earlier I said think of an image as like an image snapshot. It's actually a set of layers. Each layer changes the file system slightly. So if you imagine you had loads of tar files, and you were going to untar them sequentially into the same folder, and later ones were going to overwrite the newer ones, that's kind of what the layered file system is like. The reason it's like that is that the way Docker and registries store images, they don't have to store the same layer twice. Let's talk about Git again. If you've got a million branches that all have a common ancestor, there's not lots of copies of that in your Git repository. So if I've built loads of images that extend PHP 8.2, my registry will have all the PHP 8.2 layers, and then it'll have only the bits I've added on the end for each tag. So let's look at some of the commands you can have in a Docker file. I should mention, actually, there are other projects that build images from things that aren't Docker files, because once the image is built, the kind of the source code is discarded. So there's some sort of cool tools for writing the syntax completely differently. So the add and copy instructions both take files and put them in the image. Remember, an image essentially an image is a file system with a bit of metadata about how to run it. So the thing we're mostly interested in is how do I get files into here? There's two options. Add came first, copy came later. You mostly want to use copy. Add has magic, and that's why they added copy, to be less magic. The link flag, just put it in there. It makes it more efficient. So the top example, I'm copying two files into the image. That's pretty simple. So it will create a layer that says, add these two files in, and contain the files in the layer. This is quite cool, I can copy from a different image. So I can say, I want an image out of the composer public image, please. Can you copy it into my image? And while you're copying files, you can change ownership, you can change permissions on them as one operation. So if you need to copy it as a particular user or add an executable flag or that kind of stuff, you could do. Add is where the fun stuff happens. So add you can use to copy local files. But then if one of the magic things is triggered, you might be confused. So if I add a tar file, it gets untarred for me, which might not be intuitive. But I can add from a URL. That's nice. I can add a file at a remote location. And something that only got added quite recently, I can add a file from a Git repository. I can specify the branch and I can specify the file to copy, which is cool. And we'll talk about caching a bit later, but those two remote adds have good kind of caching built into the builder. So if I've built this before, the builder will do a head request to that URL and try and figure out if the zip file's changed. Similarly, it will keep the it'll keep the Git clone in its cache until it gets cleaned up. So next time I want to copy something from the same repository, it's got a local copy and it just has to check the local copy hasn't changed. So add and copy both explicitly bring files in. The other way files get into your container is you run a command that makes them. For instance, composer install is going to make a load of files. So every run command generates a new layer as well into your container. So in this case, it would generate a layer containing my vendor folder and probably some composer cache somewhere. And you want to minimize, when you're running, you often want to combine the commands together because in this example, I copy a script, I run the script, and then I delete a cache file because I don't want that cache to be in my final image. The problem is the way it's stored as layers. I'll have a layer that copies the script, a layer that runs the script and generates the big cache thing that I was trying to avoid. So I've got a big layer there. And then I've got a layer that deletes it afterwards. So you'll tend to see run commands squished together. So here I'm still doing the two same operations, but at the end of it, there's no cache, so the cache doesn't end up in the layer. But don't go too crazy micro-optimizing layers. You have to balance it with how shared they are with other images. So here we get 3 layers. That's the gist of how you build things. I'm going to talk a bit about caching because there's a lot of projects I've joined have complained about how long their builds take, and it seems like an underappreciated field. So layers are cached sequentially, so the order is really important, the order of your layers. So this is a very simple Docker file, and I've slightly cheated by not mentioning how Composer gets into it. But you imagine I'm going to take the public PHP image, copy everything into it, copy my code base into it, and then run Composer install. First time round, fetching the PHP image takes 10 seconds. Copying the files into the image is normally cheap, so a very, very short time. And then Composer install takes 20 seconds because networks, you know. But the next time I do it, it's quite interesting. It does take half a second to check that the tag for PHP 8.2 hasn't changed. And then the copy takes 0 time. That's because it's not really 0 time. I've just got a fast laptop. It stats every file. It hashes every file. I can't remember. It checks if any files have changed, and if they haven't, it says, "Oh, I already know the layer that this would create. So I just used the layer I made last time." Similarly with the run, it sort of says, last time I ran, I had the same layer, and then I ran Composer install, and it generated this new layer. So I know what the answer is. I know that this file system plus run Composer install equals this new layer. That may or may not be what you want to happen. For instance, if it was a composer update, you would be using the cached composer update, if you see what I mean. If I run a command that echoes the date into a file, and then I build it again in a year's time, it'll use the cache, and I'll have the old date there. It's only going to redo it if the layer before changed, or if the command has been changed. Like I added a flag to composer. So in this case, because I'm copying everything, if I touch a file, then it will run composer install again, because the builder doesn't know which files affect the output of composer install. So it says if anything changed, then I have to assume that this instruction is going to produce a different result this time. So you end up ordering things around a bit. This is a sort of longer version of the same thing, but here I'm copying composer in. I'm copying the files composer cares about first, and then running composer install, and then I copy the rest of the files. So the difference is, if this, that doesn't work. If this, I can move. If I make new files in my code base, all of the stuff above it can be cached, and it will just have to run this command, which is my sort of warm cache command. So if I'm editing stuff, this copy has to run and this has to run again. And it's only if I edit one of these files, if I edit the composer JSON, next time I build, this will hash to a new hash. It won't know what the result of running composer install will be, so this will execute again, and it goes downwards. So you have to sort of think about what order of operations you want, and think about which files are going to change more often, and put them towards the end. And things that never change, like the apt install, some dependency, can go at the top. And if you've got your cache set up correctly, a lot of these things will take 0 time in sort of day-to-day. And this isn't a talk about optimizing builds, but another important thing to look at is multiple stages. So this is an example where we've got 2 from statements. What this means is I can ask the builder to build either one by giving a flag and giving the name of the stage, final, or composer installer. Or by default, we'll build the last one. And I can copy things between stages. So the graph for this ends up like this. And an interesting thing about it is that BuildKit, the builder, will parallelize these builds if you've got enough cores, or if you've given Docker enough cores. So it will pull the PHP image. In the left-hand one, it will pull the composer image and install composer. In parallel, it's copying all my source code into the final image. And then it copies composer JSON, composer.lock. It runs composer install, and the final one will have blocked. So if it's got to the point where it wants to copy from vendor, it'll block there, and then it'll copy the vendor folder over into the final one and run. So the output of this is going to be slightly different to this one, in that composer was only copied into the composer installer image, so the final result won't have composer in it. I'm not as worried about any temporary files that composer install have made, because I didn't copy those over. And there's some interesting differences in how cache invalidation will affect it. In general, BuildKit builds, you can have loads of these things and everything getting copied around. And BuildKit's kind of building a graph of it and figuring out which things need to be built to get your final result. That was a diversion. So some more stuff you can do when you're building an image. Arg is how you parameterize your build. You don't want to you might want to build multiple PHP versions, for instance, if you're doing a kind of matrix-style CI. You might want to, I couldn't think of a good example, so I've said the code base needs to know the Git hash for some reason. I have worked on a code base where that was in the requests and responses in dev mode, so it's not too obscure. So build arguments have to be passed in explicitly. They can have defaults, and they change your build. Env is sort of a related command that sets an environment variable in the resulting container. So if you want your container to have certain environment variables that your script is interested in, you can set them in the build. You can also change the working directory and the user. So if you do that in the middle of a build instructions, it basically changes the current working directory, changes who is running the commands and stuff. And then at the end, whatever the last worked and user were, is the working directory of the finished image, and the user that things will run as in the finished image. Containers mostly run as root by default. And lastly, so all of that was to do with what files are going to be in the image. The last thing you have to configure is the entry point and the command, which together tell Docker what to run when a container is started from that image. Which one process is going to be the winner? Is this a web server? Is this a shell script? Is it a database? The reason it's split into two is that the entry point is, well, you just imagine they're concatenated together. In the PHP image, the entry point is user bin PHP. And then the command is, whatever you type after PHP to give it flags. And you can override that when you run them. So at this point, that's pretty much how you build an image. You write a Docker file, you commit it to your repository, you write a command that whirs away and spits out an image. You specify a tag for the image, so you have something to call it. And then you'll have the image locally in your Docker registry. When we run an image, we want to be able to control it. We want to be able to change stuff at runtime. You don't want everything to be hard-coded into an image. So one thing you'll want to do as a developer is a bind mount. Docker has a whole concept of volumes, which at runtime they can be attached to containers and shared between containers if you want containers to share things. The thing you'll mostly be doing, it's called a bind mount, is you're mounting a file from your host machine into a specific place in the application. So in this example, I'm taking the generic PHP image. I'm mounting my code base into it at /app, and I'm setting my working directory to /app. And then I can run PHP unit, and it runs. So those files aren't in the image. It's sort of there's the file system that's been built into the image, and then you're over-mounting whatever you want from whatever location you want on your host file. This isn't something you do in production, but when you're working on a code base, especially PHP, where we don't have big compile steps, you probably want to mount your working folder into the container, so when you edit a file and go and refresh your browser, it's been updated in the container as well. For shipping to production, you want to be baking the files into the container, into the image. The other way that you configure containers is through environment variables. So any sort of runtime config, URLs it needs, things that are going to be different between boxes, you tend to detect it from environment variables. If I try and run MySQL, which is the official MySQL image, Docker calls all the library / stuff official images, but it means Docker official. So if someone says the official PHP image, they mean the one that Docker says is the official image. It doesn't mean it was generated by the PHP maintainers particularly. So the MySQL thing has some environment variables that have to be set. So I can run it with env, set what the root password is, and then I have a working MySQL server running in a container. And I know the password. I'm sure you can imagine why you don't hard code the password into a database container. Another thing you'll want to do is to access that container. So containers are isolated and you can't easily connect to them. It defaults to running in a bridge network, and you can publish ports from the container to your local host. So here I'm publishing the MySQL port to the same port on my local machine, And I can connect to MySQL just using localhost and that port. I put protocol equals TCP here because MySQL does an annoying thing. If you have a MySQL server already running on your machine, and you say, I'd like to connect to localhost on this socket, please, it sees localhost and it says, oh, he doesn't mean that. He wants to connect to the MySQL server actually on his host through a file socket, and I'm not going to mention I've done that, and he'll spend half a day figuring it out. More than once, because he forgets. So that's it. That's running containers. We've seen building images, running containers from them. That's a creepy picture. The layer above that is orchestration. So if you were typing Docker run this container, and then you have to remember to then run the other container, because we don't just deal with one process at a time. We want to have a PHP app server, a web server, a worker, a database. Running loads of Docker commands and hooking them up together would get painful. There's a whole networking side where you have to create a network and then make sure your containers are in the same network so they can see each other. So Compose is a layer above this that deals in services. It's very commonly used in dev and CI. Docker sort of tried to make it happen in production, and it didn't really work out, and Kubernetes sort of won quite significantly. But it's almost a no-brainer for, I want to add something quickly to my project that will let me spin up all these things together in a coordinated way, and all the tools will use it. It started as a Python project. It got adopted by Docker. Again, like these things tend to happen, the config spec moved to an open standard, which is it's good that that happens. And a couple of years ago, it was all rewritten in Go. It used to be a bit annoying because when you installed it, you'd get all of Python from your package manager as well, and now it's just a binary that you can run. That's not a diss on Python. I don't think PHP is a good language to write command line tools for people who aren't PHP developers in as well. And the main thing with Docker Compose is that it's a YAML config that just specifies what containers are going to start. If we need to build any, how are they going to be built? And then how are they hooked together? So it's the kind of thing you could do as a makefile with all those Docker run commands we've been looking at, but it's config, declarative config. So the main thing to think about is services. I'm going to show a sort of typical PHP app. So I might have an application server and a web server. That's annoying that we have to do that still. There are solutions to not having two separate things. One solution is use Apache, but often you'll tend to have an Nginx and a FPM service. FPM would look something like this. So we're not going to build all of these things, but the PHP image is something we're going to build. So the YAML config, just the build section, pretty much maps over to the flags I would have passed when I typed docker build x build. It's the same stuff. So I say what the build context is. I say where the Docker file is. I can pass in a build argument. And then there's some runtime configuration as well. When you bring this up, mount my development version of this project into the right place in the container. Pretty simple. For Nginx, I'm not going to build that. I'm just going to use a public Nginx image. You might decide to start building your own Nginx image if you reach the limits of how the configuration stuff that's been built into it. Or there's fancy stuff you can do in production with fast CGI ingress things, so you might not even be using Nginx. So in this case, there's no build section because I'm not going to build it. Instead, I nominate an image. I say, use this image. And they tend to be pretty user-friendly, these images. So the Nginx has a location that you can drop templated config files into. So you have a sort of template of an Nginx config, and then it interpolates in the environment variables into that file and then uses it to boot Nginx. So I can plug in I would have used these environment variables in my config file, and then I can sort of change them at runtime. And the important thing there is that we're pointing the fast CGI thing from Nginx to app, which is the other service. So Compose takes care of this DNS, so app now points to that other container. If you want longer URLs, there's a thing you can add. And I expose the ports locally, and I do a sort of user-friendly thing where if the developer already has something running on port 80, they can override it to a different port. I want a database. Similarly, MySQL has a thing that lets you set the password. It also has a folder you can drop config files into. It additionally has a nice thing where there's a folder that you can put .sql files into that will get loaded in at boot if you want to seed your database that way. RabbitMQ as well, why not? All of these, I'm not building my own implementation, I'm just configuring public images that someone else maintains. And at the end of all that, I have to go back to my app and give it some connection details for the database and the queue. Again, I'm using the service name, so the keys in the YAML are the names of the boxes, and you can call it something.local if you feel that's less confusing. And the assumption is my PHP application is going to read the environment variables for its config. One last thing I can do, I might want to have something that's processing the queue, and instead of building a completely separate image, I can use a fancy YAML anchor. That's a YAML feature, not a Docker Compose feature, to say, yeah, this service is the same as that one, except instead of being an FPM server, it's going to run this command. So I write all this YAML, run it, and what I see is a load of build output. I see it pull all the images that I've asked for from the public, and then it brings up all the containers. And at some point later, I can connect to port 80 and my system's running. And there's a worker processing the queue, and the logs start appearing in my terminal. That's it. That's the Compose workflow. Last thing I wanted to talk about was how you might, that was for the developer, local developer, how would you then apply that into a CI pipeline? And here's a way of doing it. Compose lets you specify more than one file to read. So if I set this compose file environment variable, Compose will take the sort of main one that we wrote for the devs, and then we can add stuff to it that is CI specific. Depending on how shared your runner is, you might want to set the Compose project. I won't explain what that is. It'll collide if you've got loads of parallel builds on the same box. You want it to have a unique ID. And then I can write some YAML that adds a couple of things. I want to add an image name to my PHP image, the one that just had a build. I want to add an image name, and that image name is going to be unique to this pipeline, or unique to the Git commit, or something like that. That's where it's going to get pushed to. And there's some cache to and cache from stuff that you should explore. So if you've got short running sort of on-demand workers, the build caching stuff we looked at earlier, the cache won't be populated, but there are some mechanisms for sharing the cache. You can push it to a registry. You can stuff it into GitHub Actions. There's a few things you can do. Because that's the ideal scenario, is if you trigger a build, the Docker image build should take almost 0 time. It just needs to check if anything's changed. Ideally, things will be cached. And so for a simplified build pipeline, the first step will be build all the images. So it will push a tag like this that's unique to the build. It'll build the image and then tag it in the registry with an ID that's unique to the build. So even if you've got a big fan out of lots of different things you're doing in CI, do one build. Don't build the image loads of times, it's a waste. The validate steps, the middle layer, they can pull. Because they've got the same ID, they'll automatically get the same image. You might not need that if your runners aren't like all completely separate, but most of the time, I'm trying to do these 3 things in parallel. So they pull the images, it should be very quick, and then they run whatever test they want to run. And then to distribute it, after a tag, or maybe you always distribute passing builds, there isn't a nice way to do it just in Compose, but basically you use Docker tag to copy the image from the tag that is the unique build to the registry it's actually going to go to for delivery with a version ID or something. So you might push version 1.0.0 after everything built successfully. So you temporarily store a tag that is, the hash of the CI run, and at the end you tag that with a release, or you push it to main, or whatever you want to do. And in general, a lot of the ways production stuff will be configured, or one of the ways you can configure production stuff, which isn't in scope of the talk, is that it's just constantly looking for when a new image is published, and there will be some rules. Whenever a new FPM image appears, spin up a container off of it, slowly move traffic over. That's all production stuff that I try not to get too involved with, because I don't want to carry a phone around. So hopefully that's the whole pipeline. We saw how some of the fundamental concepts, we saw how you run someone else's image, we saw how you build your own images, and hopefully you've got an idea of how you tie it all together with YAML and get it coherent. So thank you very much. I need to know if we have time for questions.
Yeah, I think we've got about 10 minutes if we need it.
Oh, that's great then.
So, any questions? I'll run to you with the mic if you don't mind, so everyone can hear the question.
This is always the scary bit.
Hi, great talk, thank you very much. I just have a question about copying, if this is in scope, copying tokens to containers to authenticate with things like GitHub repositories. Yeah. What's the best practice for that?
Don't use an argument. Don't use arguments, because they're visible in the image afterwards. There's a thing called a build secret that is probably the best way to do it. There's actually 2 times you might want a secret, actually. There's runtime secrets. So it might be a secret that only needs to be used when the application's running and might change over time. And there's a mechanism called secrets that I didn't kind of go into, where you can either set an environment variable in the container, or you can mount files into a specific location in the container. So you might want to, so you have your secrets in some secrets manager, and then when the containers run, a file in a specific location has the secret. That's the sort of runtime stuff. And there's an equivalent called build secrets, which is for secrets you need during the build, like authenticating with the Git repository, and it's a very similar mechanism. So it's just some extra flags at the CLI or in the YAML.
Any other questions? Jesse, is one behind you there?
Oh no.
Thank you for the talk. I saw on some of your slides you had a reference to Alpine images. So they are like stripped down, like smaller versions. Would you say it's a good practice to use them? Because I know there is some debate around it.
Is Derek in the room? If you ask Derek Rettons about it, he'll tell you why Alpine's terrible. I think there's not as much of a margin in it anymore. A lot of the public images, for instance, PHP, you can ask for the Alpine version or the Debian version. The Debian one is very stripped down now. I think people's obsession with the size of an image maybe isn't as important, but I've certainly used Alpine for stuff. I keep meaning to check out ChainGuard as well, which is an even more stripped down Alpine-y thing. In general, I guess you want to have as few files in a container as possible, mostly I would say for security reasons, rather than image size reasons. But you kind of want to know what's in there and is it affected by any vulnerabilities and that kind of thing. So I don't have a strong opinion about using Alpine. I do.
Thank you.
Yeah.
Okay, I think we had one more over here as well.
Hi. So a question about bind mounts. So we use bind mounts in development, and on larger projects, they tend to get very slow on macOS. Do you have any tips on that?
Minimize the amount of stuff. The reason for that is that on Linux, bind mounts are, there's no overhead. On Docker Desktop for Mac, you are mounting the file into a VM, into the Linux VM, and then that's getting bind mounted in, and it's the first step that's the problem. So Desktop for Mac has 3 different mechanisms for it. None are great, and there are competitors that do it a bit better. I've can't remember the names of any of them now, but there are other products that have slightly more efficient mounting options. It's annoying. You can often just take out a lot of the mounts that for the files you're not working on. It's especially a problem in PHP. So one of the reasons it's painful for us is that you mount loads of files into the container and they're all used at runtime for your local dev. You know, you're not op-caching it. If you think about a Java workflow, they output a .jar and there's one file sort of running the application, whereas we're like constantly including PHP files, so it's much more escalated for the interpreted languages. And I think most of the developers are Go developers and don't have that pain. So they don't care so much about it. I know some people use mutagen, which kind of, it's okay, but you need to add lots of extra config just for the Mac users. Just have some patience is what I say.
All right, thanks.
When you were building the PHP image, you specified 8.2.
Mm-hmm. Yeah.
Why? So that 8.2 tag keep changing presumably. Why would you pick 8.2 over say 8.2.1? Or does it not really matter?
It's a very good question actually. So what's going to happen here is that every time PHP is released, my base image is going to change and my cache will get invalidated. But as long as I'm regularly pulling PHP 8.2, I'm going to get the latest version with fixes in. So I think it's more of a question for, I think if you're pinning to a minor version, which I have done on projects, you need to make sure there's another mechanism in place that's going to tell you when that needs to be updated, something like one of those bots, the Renovate bot, that's going to say, hey, you're using a PHP version that's behind and make a pull request for you and stuff. So you can have that explicit control. You can also pin to a SHA. So you can say 8.2 at, and then a hash, and it will always get that hash. It kind of ignores the tag in that case, and just uses the hash. There is some stuff in the pipeline where you can have, I don't know if it's been merged yet, or just proposed. There's an idea you can have a separate file that resolves all the references into hashes, and you'll be able to input that into build kit sort of separately during the build. So you can say during this build, treat all of these short versions as this hash. Or at least tell me if it's not true anymore. That sort of thing. There's a whole software bill of materials feature that's been added where you get a huge audit of everything that's in your image that you can compare to security advisories and things.
Okay, anything from the left-hand side of the room? No, we're good. Everyone wants their lunch, I think. Okay, thank you again to Kieran.
All right, thanks everyone.
Yep.
we'll leave you to it.
All
Thank you.
right. Well, as he said, welcome back from lunch. If you are looking for performance-driven development by Jim or doing bad things with APIs with Tim, you are in the wrong place. If you're looking for Lambda on, well, PHP on Lambda, then you are in the right place. I am Ian Littman, and, well, you can follow along with the link shown on the slides. You can follow me on socials as shown on the slides. Other than that, let's get right into it. So, in this talk, we'll go over a little bit about why you would potentially want to use Lambda in a couple of cases where it's like, okay, well, there's performance implications of what you do on Lambda. There are billing implications of what you can do on Lambda, and you still might want to use it. And the thing is that Lambda doesn't have a PHP runtime built in, so you kind of have to bring your own. And we'll walk through how exactly to do that, starting from kind of the ground up. And we'll see how that works in a couple of contexts. One is responding to events asynchronously, basically responding to an email with another email, and kind of utilizing this stuff that a few of the 300 plus or 200 plus services that AWS provides. And we'll also see Lambda operating in an API context with both API gateway and function URLs, which is simpler than API gateway and costs less money and has some limitations, but you may not care about those limitations. In addition, we'll talk a little bit about the new container image support within Lambda if you need to do something a little bit heavier, and depending on time, we'll touch on Bref. Okay, realistically, we'll touch on Bref anyway because it's super quick to get started, and that's what you should be using in production rather than the things that I'll be walking you through. I'll show you the hard way, and then Bref can be the easy way. It involves NPM, though, but we'll forgive Matthew for that. So with all of that, there will be a fair number of demos toward the end of this presentation, and hopefully the Wi-Fi stays good enough that I can upload a 5.5 meg file. So, without further ado, there are a few things we will not cover. For example, fully automating things outside the context of Bref. We're not going to do AWS SAM, which is the way to kind of run serverless functions locally for testing. We aren't going to deal with Laravel Vapor. A few other items here that, for the sake of time, we won't touch. So, the thing with Lambda is there are no servers to worry about. There's no container runtime to worry about unless you really want to worry about that with a Docker image. You just upload your code, and it just runs. And it just runs in a way that is billed on a very fine-grained basis. It's actually billed per millisecond here. The last time I did a version of this talk in 2020, it was billed per 100 milliseconds, and now it's a lot more fine-grained. And each execution is shared nothing-ish. We'll get into the caveats there in a moment, and we can use those caveats to our advantage. But you can scale out from 0 all the way to 1,000 or to potentially more concurrent invocations of whatever your code is. And you don't have to worry about auto-scaling or the amount of time that it takes to do that. Your functions, little bits of code, scale in a matter of hundreds of milliseconds. So this is made possible by something called the Firecracker micro VM that AWS built a while back and now uses both in Lambda and in their serverless container service, Fargate. So this is all well and good, and also on top of the scaling benefits that you have with Lambda rather than trying to scale up and down servers that scale on the order of minutes rather than hundreds of milliseconds, you have the ability to integrate with various AWS services which AWS uses to a fault. In a lot of blog posts, they'll say, hey, here's this simple thing that you can do with only 25 easy steps involving 3 Lambda functions, step functions, an API gateway or 3, and 4 or 5 other services. Lambda tends to be at the heart of a lot of those posts because you can listen to events from various sources and react to them either synchronously or asynchronously. So as an example of those interactions, you can watch for files to be added to S3, which is what we will actually demo later on in this presentation. You can listen for notifications on a simple notification service. You can watch for messages in simple queue servers, or SQS, either individually or batch. There are a few ways of handling things there. So you can have a queue worker set up that that scales so rapidly that either you don't really have a queue backlog to speak of, or you bring the services down that don't have very high level of quick scalability. One of the two. Now, if you want to serve HTTP requests with Lambda, then it's honestly a little bit more involved than it should be, but as time has gone on, they've made it easier. There are really 3 different ways of serving HTTP traffic onto a Lambda. One is via the application load balancer, the thing that costs you roughly $25 a month, plus traffic and such. And you can set endpoints on the ALB to route to Lambda functions. Alternately, you can set up an API gateway and map routes to Lambda invocations. Finally, and this is a relatively new addition to Lambda, there's something called function URLs, which expose, using the same event format as an API gateway, they expose your Lambda functions directly as, well, URLs. And you can either not authenticate them at all, or you can use AWS's IAM system and permissioning to authenticate, which I'll mention a little more detail later. Finally, if you don't need to call something over HTTP, you can use AWS's API to pass data to Lambda directly. They have an API for Lambda invocations as well. So plenty of ways to call Lambda. Again, there are a number more of these, and as you'll see later in the demo, there's a big long list of event sources that you can tell Lambda to react to. So I said shared nothing-ish. That's because Lambda actually keeps your little function invocation around, or sorry, function instance around across multiple calls, what Lambda terms as invocations. They have a bootstrap phase, or cold start, where things get set up, and then they'll run requests through until you either have an extended period where you just don't need that level of concurrency, or something fails, or you time out. Now you can set that timeout. This is within the execution of a function, so you can set that timeout up to 15 minutes. If you're serving a web request, obviously it's going to time out well before then. If you're running some sort of batch processing job, you might run up against that 15-minute limit, at which point Lambda will say, well, this execution context has gone off the rails. We're going to shut it down. Anyway, the containers get kept around a bit so that they can respond more quickly to requests as they come in, because there is some level of overhead measured in hundreds of milliseconds, or maybe 100 milliseconds depending on what kind of code and how much code you're running, to get that Lambda started from scratch. Now, once that particular instance of Lambda gets set up, it has access to /temp. By default, that's a 512 meg partition, so if you need to cache data quickly, locally, realizing that that cache is not going to be available to any other concurrent execution of Lambda, you can throw it in /temp, and 512 meg of /temp is free, and you can get up to 10 gigabytes of cache in /temp if you are willing to pay for it. So in addition to that, you can persist state to, of course, S3 or a database like Dynamo or MySQL or what have you. Or you can attach Lambda to the Elastic file system, which unfortunately is rather slow, so you want to use that carefully. So there's this concept of invocations versus instances. An invocation is a processing of a single event that is provided to a particular Lambda runtime. And you can have multiple of those invocations back to back to back over the lifetime of a given Lambda instance, effectively a VM or a container, as you will. So what this does is, again, it allows you to run a little bit more quickly than if you had to build every single thing from scratch every single time. Now, one thing that Lambda does not do is, per each instance, process multiple requests concurrently. So if you have 10 web requests coming in at the same time and you're using Lambda in that context, then Amazon is going to spin up 10 instances of that Lambda function. Those are going to have each their own /temp, and each one of them will have its own little sandbox to execute based on that request. So it is shared nothing when you're doing multiple things at a time. So instances are different than invocations. Instances, simultaneous instances, are where you get your concurrency. Unlike things like Google Cloud Run, where you can throw multiple concurrent requests at a single container, on Lambda, it is one at a time per instance. So, a couple more items on performance. Historically, the amount of RAM that you could throw at Lambda was between 128 meg and a little under 3 gigabytes. Relatively recently, they increased that maximum amount to 10 gig. So if you have some really heavy, crufty script, then you can throw it in there and it'll still work. As you scale up RAM, they give you a proportional-ish amount of CPU. 128 meg does not give you much CPU, and it actually throttles your CPU time down, so functions will run more slowly at 128 meg than at 512 a gig, or roughly 1.8 gig is where you get a full core of CPU time all to yourself. Given that we're talking about PHP here, one core is all you're ever going to need on Lambda because, as mentioned earlier, you're only processing one request in a Lambda instance at the same time. You're not going to get performance impact above that, so basically don't bother with something larger than 1.8 gigs unless your script just is super memory hungry. To that end, Bref and serverless framework in general have a default of a gigabyte of memory allocated to the function, which gives you the lion's share of a single core, and that's usually enough to have a proper price performance benefit because the amount of CPU time that you get and the amount of money that you pay both scale linearly with the amount of RAM that you allocate times the amount of time that you keep the function running. Now, that also means that there is kind of an optimal bit where your function runs quicker the more power you give it, which means that it takes less build time, which means that by throwing more resources, you may actually end up with your function costing less. So, and again, with that 10 gigs of RAM, you can have up to 6 cores, although, again, you were talking PHP, so you're not going to do anything useful with them. There are a few other limitations that are here. If you pull a copy of my slides, that is linked, and that'll take you to the AWS page where it goes into detail on a few other limitations that you may or may not have any likelihood of hitting. So, as mentioned on the billing side, you're billed on gigs of RAM per second at 1 millisecond granularity, which means that like there used to be 100 millisecond granularity that would mean like, okay, make sure that you don't have a function that runs on average for 201 milliseconds, because that's going to cost you 50% more than one that ran for 199. That's no longer really an issue. It's super fine grained, but if you throw more resources at a function and it runs proportionally faster, then your end users get a better experience, and you wind up paying the same or less. Now, billing includes execution time even if the CPU isn't doing anything. So if you have a Lambda function that is sitting there and calling an API that takes 10 seconds to return, congratulations, you just spent 10 seconds worth of Lambda billing time and have maybe a web response to show for it. So for things that are very I/O weight driven, particularly operating over HTTP, Lambda, particularly if you have a kind of consistent level of scale, may not be the most cost-effective thing out there. Like the prices aren't horrible, but if you have consistent load and are waiting around for I/O a lot, then it may not be the greatest use of your money. So another bit here is relatively recently Lambda added support for ARM CPUs as well as x86, which is what they've had from the beginning. The ARM architecture, similar to the machine that's sitting in front of me, does require binaries to be recompiled for that architecture in order to work. If you get the recompilation done, which PHP runs perfectly happily on ARM, then you get, I believe, a little bit less performance versus the x86 instances, but also things cost, I want to say, about 16 or 17% less. So you've got an option there, and if you wanted to, for example, build something locally and compile something locally on your Apple Silicon Mac and actually have it work on Lambda, that's fine. You can totally do that. They support ARM there too. Another note here, there are two stages, the cold start initialization phase and the warm start and execution phase. In the case that we're talking about for custom runtimes, which is what you'll need to use with PHP, you are billed for both. But based on the latest that I've read, you do get a bit more CPU during the initialization phase than you do during execution. So initialization phase, at least historically, you'd get 2 cores even if you only have 128 meg RAM. So if you want to do some heavier work on the Bootstrap side of things, then yeah, you'll get a little bit more compute there, even if you spec things down later on. So one thing with Lambda is Virtual Private Cloud, or VPC, has some limitations. Now, of course, you need Virtual Private Cloud, and you need your Lambdas inside of that when they need to reach out to some piece of your infrastructure that is also VPC only. So that might be your database, that might be Redis, something to that effect. The limitations there are, unless you have a NAT gateway which costs 5 cents per gigabyte and 5 cents per hour, even in the London region, they bill it in US dollars. You have to have that set up in order to cleanly get access to the internet from your Lambda within a VPC. If all that you do within that Lambda is contacting things that can be reached within the VPC, You don't need the NAT gateway. So what you can do architecturally, if you need stuff in a VPC and the cost of outbound transfer is an issue because you weren't planning on setting up a NAT gateway and having it sit there and bill you for your serverless thing. If you weren't planning on doing that, you can split your architecture to where anything that needs to contact internet-facing services is in a Lambda outside the VPC, and anything that requires connectivity within the VPC is split off, and you just have one function that's contacting internet-focused things and another that's not. Of course, you would then need to set up some way for those functions to talk together, so throwing things onto a queue or S3 or the like. So it's a question of, do you want to spend more dev time architecting that, or do you want to spend more money subsidizing Amazon.com? So one thing that used to be an issue with Lambda inside the VPC was cold start times. You would see 10, 15-second times to get a first function call running if the function had gone to sleep or hadn't been called to start with. That has not been an issue since 2019. Things are just as fast inside the VPC as they are outside. So I've kind of set the stage here, and we really haven't talked about PHP on Lambda other than saying you only need one core. So the way that PHP works on Lambda is you kind of have to bring your own runtime. Now, there are two ways to do this, and this presentation will primarily walk through the way that involves uploading a zip file with the basics and then uploading another zip file with your PHP code. That uploading the zip file with the basics is you take an Amazon Linux 2 instance, and then you compile your PHP runtime against that, and then all of your library files and binaries and such. You take those, you throw them into a zip file, and you upload that as what they call a Lambda layer, which again is just a file system that they drop in /opt. So when you define a Lambda function, you can say, hey, I'm going to cherry pick this layer and this other one and stack them in whichever order you want for that particular function. And then you have access to those files and thus that runtime on whatever function you're running. So by doing that, and by using the kind of Lambda custom runtime endpoint API that we'll go into in a second, you can actually run anything, whether that's a shell script or some esoteric language or PHP, within Lambda, and it will work. The other way is via Docker container images, and we will get into that in a minute. So one thing that is important to note here is Lambda does not speak HTTP. Lambda has its own event format because the way it was initially built was like, okay, well, we're going to have, something was uploaded to S3 and then we're going to act on it. So being event-based, you get this big blob of JSON back saying, hey, a photo or a file was just uploaded to S3. Here's what happened. Here is all the information that you need to maybe do something with that file. Now, there are events that represent an HTTP request, including headers and a body, etc. But those events are not standard HTTP messages. You don't go in and set up a PHP web server and then expect Lambda to send you HTTP requests on port 80. So anything that you do in PHP land needs to have an abstraction layer between your code and what Lambda is doing, or you just kind of do what Lambda expects. And it's all about calling Lambda's HTTP API rather than them calling you. So As mentioned, layers are built on top of Amazon Linux 2. You zip them up. You push them to AWS in the layers area of the Lambda UI in the console or via API endpoint. And then you reference those layers or somebody else's layers. In the case of Bref, they have layers pushed that are publicly available. So you can use those instead of your own. So now let's get into this custom runtime lifecycle. I told you it was kind of weird compared to just setting PHP-S or Nginx or FPM. So on Bootstrap, AWS will, in the case of not using a Docker container, it will look for a file, I believe it's /opt/bootstrap, and it will run that. And that's supposed to set things up, and if it's not successful, it'll return non-zero. If it's successful, then you'll set things up and start asking AWS on URL that's determined via an environment variable. Hey, what work do you have? And then you process the work, and then you send the result back, and then you clean up, and then you ask for more work. And that the amount of time between calling that initial Bootstrap file and asking for the initial set of work is your cold start, plus whatever Amazon does in the background. And then after that, the time between you requesting new work and Amazon handing something back to you, that part of the workflow is a warm start. And yes, that means that your HTTP request to ask for more work may time out, so make sure it doesn't time out. So again, there is a limit to how long your function can sit there and process. I think the default is a few seconds, and you can push that up to as many as 15 minutes. If you have a longer running job than that, you will need to split it up or not use Lambda. So on Bootstrap, AWS initializes the runtime and pulls down whatever files are associated with a function, whatever layers, and then it sets a bunch of environment variables, and then calls your Bootstrap file, which should either get things ready to call to AWS and ask for work, or it should call an API endpoint saying, hey, I had a problem starting up. Once you've gotten to that point of a successful startup, then you ask AWS, hey, give me the next event, next invocation. It'll give you a response. You process that response, and then make a call back to AWS with a result of that processing. In certain cases, for example, the HTTP API stuff, whether that's through API Gateway or whether that's function URLs or the application load balancer, there is an expected format to that response for your response body and headers and status code. It is, again, not an HTTP message, but it's pretty straightforward. It's JSON. They no longer require you to do crazy base64 encoding of stuff. So while it's not just HTTP out of the box, it's not that hard to adapt things. And if you do have an issue running through your code, you can call an error request via that internal AWS API and say, hey, this didn't work. And at that point, AWS will close out that function and that instance and start a new one going forward. So one thing here is you can do cleanup. Of course, the clock keeps running, the billing keeps running. You can do cleanup after you send a response back to AWS, but before you ask for additional work. Just realize that that is build time, so you don't want to just sit there doing cleanup forever and not ask for another chunk of work. So your error logs do go into CloudWatch. You can actually see what's going on there. There are metrics that are visible on the function side as well, including function duration and that sort of thing. And there is a telemetry API that is available per function execution that you can hook into. It operates over HTTP. That is out of scope for this talk. That is quite new. I believe that was actually announced at the most recent reInvent. But if you do have an error during the process of running the function, then you make another post call to this special Lambda API endpoint. So with all that said, that API is what you use whether you are running off of a Docker image or running off of a zip file. But if you want to, for example, not use something based on Amazon Linux 2, you can provide a Docker image, push it to a Docker registry. The easiest way of doing this is using Amazon's own Elastic Container Registry, or ECR. And then you can tell Lambda to use that rather than a uploaded zip file with the code in it. What that allows you to do is, again, use other base images and really treat your Lambda setup similar to what you would in a normal container. Now, caveat to that, again, is you still have to use the Lambda HTTP API to bootstrap, ask for work, etc. So you're still not going to be serving HTTP over this container. Now, that Lambda API is, they have the runtime interface client is what they call it, that implements that for you. And Amazon does have some base Docker images that include that client. The problem is, there does not exist an official AWS runtime interface client that speaks PHP. And also, as an added bonus, the Node 1 does not work for Node 17 and above. So, in this case, as you'll see in the demo portion of this presentation, we do have a little bit of code that interacts with that API directly, so we would just use that, continue to use that even in the container environment, and we're fine. Now, because that is kind of a weird API, Amazon has said, all right, well, we want you to be able to test this stuff locally in a containerized environment, pass events to it and get stuff back. So if you add the AWS runtime interface emulator, which is a binary, they have it for both x86 and ARM. If you add that runtime interface emulator binary and change your Docker command to be that temporarily, you fire up the runtime interface emulator. You tell it, okay, once you are set up, run my standard bootstrap file, which in this case can be anywhere in your container. Amazon doesn't care. They'll pass you the environment variables and leave you to do what you will. So yeah, the runtime interface emulator, it'll set up its own HTTP server and then call your bootstrap and go from there. And that'll allow you to test things locally. We're not going to demo that in this case because our setup is trivial enough that we'll just demo it in the cloud. But it is available, and Amazon does have that documented as to how to call that. You hit a single post endpoint, and you can pass an event body in there, potentially one of their test events, and see things process through. So with all of that, so my theory here, and again, this is not going to be exact on how AWS actually operates this, because they, for example, reserve the right to set up, to initialize Lambda instances ahead of load or whatever they want to do. But the idea here is when a request comes in, they check to see whether there's already a Lambda instance up and running. If there isn't, then go through the cold start process, run the bootstrap file, make sure that it gets all the way through and asks for work, then provide a response back with that unit of work, then wait for the response endpoint to be called, hand that back to whoever requested that event, and then keep the clock on billing until another request is made for the next unit of work. And potentially suspend animation on that Lambda instance until there is actually another event to process. So that's kind of the run through on what's more or less happening on the AWS side. It's great for event processing, a little bit weird for HTTP, but it's not that far out of line. So with that, we come to the demo portion of this presentation, in which I take a random string that I email or provide as an HTTP request, and then randomly capitalize it and hand it back in as mocking of a way as possible, which is fine because it's just mocking its creator. So first off, we're going to use Lambda for event processing in an asynchronous way. What I've done ahead of time is I set up simple email service with MX records headed to the proper place, and email alias pushing to S3, because I did not want to wait during this presentation for MX records to propagate, etc. I also had to make sure that my AWS account was approved for sending emails. So all that's done. And I also created an IAM policy that I'll assign to Lambda saying, yes, you are allowed to read from S3. Yes, you are allowed to send emails to via SES. And yes, you are allowed to do the miscellaneous things that you do as a Lambda function. All of this is documented in the README on this repo, and I'll have a link to that repo at the end of this presentation. So what we'll do now is we'll go ahead and set up a Lambda function. I've also gone ahead and uploaded a Lambda layer with the PHP runtime already there. That was kind of, I shortcutted that by using the runtime compilation process that's built into Bref, because I did not want to reverse engineer that process, and Bref has done it amazingly. So it was a matter of run the Bref stuff, copy paste the runtime directory from there. Again, this is all in the README for this project, and then zip it up and push it to AWS. So let me hop over to Lambda here, and I'll show you where that was, but I'm not going to hit the upload button again because it's like 21 meg, and I don't want to take too many chances on conference Wi-Fi. So here we have SpongeBob base. This is that zip file. I've uploaded the layer a few times now, so we're up to version 5 here. It'll increment that if I uploaded it again. The thing that you'll do here, if you're uploading a PHP layer, is you'll specify which architecture. In this case, I had compiled it on my machine at home that was x86, so I would check the x86-64 box there, switch the runtime to custom on Amazon Linux 2 because your custom runtime is on Lambda or that now, and then upload the file. We'll back out of that because that file is already uploaded, and we'll skip to adding the function. So we'll hit create function here. Author from scratch. Set our runtime to custom with our own bootstrap. Architecture is correct. Permissions. We will use our own IAM role here with a couple of extra permissions so it can read from S3 and write to SES. And we'll go ahead and check the box for enabling a function URL and just leave the authentication open for that because I don't particularly want to deal with building AWS signatures to call my own silly endpoint. So I create this function. Now I specify a layer here that I had created earlier. Go to custom layers, find our single layer there, use the latest version, and hit add. Again, you can add these in whichever order makes sense for the project. Then, so we have a long list of events that we can use here. We're going to use S3. I already have the bucket created, so I'll specify that here. It defaults to all object create events, which is what we want. And you have to check the box to make sure that you know that you shouldn't call S3 stuff recursively and run up your AWS bill. So now we have a trigger for S3 into Lambda. The last thing we need to do is provide the code to actually run. So I'll go ahead and upload the zip file, and then we'll look at what I actually uploaded. So we want spongebot.zip. Save that. It's going to take a second to upload here. And now we have everything added in. So this is actually ready to go. I'm going to go ahead and send myself an email, and then it does take a few seconds to go through the email network and fire off the S3, saving to S3, and then firing off the Lambda event. So while we're waiting for that, I'll guide you through the code that I wrote to bootstrap this. So first off, I'm going to email So I'm going to hit the send button there. So while it's processing, the first thing we'll show is the bootstrap file for runtime, which is just a quick shell script that makes sure to call our actual bootstrap PHP file in a loop. Make sure that stays running. From there, we have, I decided to not use any libraries here and just use file get contents because that's all I needed, and log some things out along the way. Because standard out does go into Lambda logs, this tends to be useful for running tests on the function. So one of the things I do there is I spit out environment variables, but I didn't want to show AWS access token secrets because those may have a few too many permissions. So as mentioned, we have a number of requests in here to various Lambda APIs, whether that is initialization fail, execution failure, getting the actual task, and then setting those headers up into a proper setup. This line right here is to properly instrument the runtime for AWS X-Ray so that you can do distributed tracing. And then we just pass that request payload back to whoever asked for it. Likewise, when we are done processing something, there's the submit call that just makes a request back to the AWS API. And again, these are all, that URL is determined via an environment variable that is passed to us when the function starts. So this is that bootstrap file. If we look at the index file, I have both the API-facing code that we'll see in a minute, as well as the SES processing code in here. And in the case of seeing an SES event, we actually grab the entire email object because the SES integration with Lambda does not include the email content. It just includes headers. So we grab that. We have Composer installed and included in that zip upload a MIME parser. So we pull the email body out of that as well as the subject. We tack on a reply to the subject. We send that back to whoever sent it to us. And then we randomly capitalize the entire message body using MB string to lower, MB string to upper, and then provide that as part of this SES API, which we're just using the AWS SES SDK for this because it's authenticated within Lambda, so you don't have to deal with any SMTP weirdness. So with that, this didn't take nearly as long as it took for me to explain this, but we now have this going on here. So we actually did round trip properly, and that was well within a minute to actually get that email passed to us. And the nice thing about pushing emails to S3 is we have the original email body if we wanted to use that for a test event for Lambda later on, which you can specify test events in the Lambda UI and see logs directly from them when you execute them. So that is our first example. The rest are going to go a little bit more quickly. So now that we've seen the code base, let's go ahead and add an API gateway and call the same thing over HTTP. So API gateway, we'll set this up for an HTTP API, not to be confused with a REST API. Don't click that button. We will use Lambda. We'll use our only Lambda function. And let's call that sponge bot. Go here, drop the resource path, and hit the go button. This will spit out a URL that should be able to CNAME to as well. And if we go here, this output here is a Chrome extension I have. This would just be normal ugly JSON otherwise. So we've got instructions here that are annoyingly capitalized. So let me throw a query string parameter here. And hey, look, that works. And you might have noticed that this returned a little bit more quickly the second time than the first. That's because there's a difference between a warm start and a cold start. And I didn't go in and change the amount of RAM that was allocated. So this is running on 128 meg of RAM, which it doesn't actually need. I think it used like 50 meg. And this did respond in like probably a millisecond on the server side, and most of the rest of it was latency because I was lazy and ran this in US East 1 rather than in London. So to give you an idea of when I say the request is a little bit different looking, this function checks to see whether there's a version in the HTTP bit, and we just use that to say, oh yeah, this is HTTP request. And if it is, then we've got query string parameters set out as their own JSON array. There's no need to parse those. And then we return JSON with a status code, and then the body that we just go ahead and JSON encode that, which then gets passed back as a string to the API with content type of text plain by our Bootstrap. So this is our request processor. It's not using any PSR fun, but that gives you kind of an idea of the format of that inbound event from Lambda. So the next example that we're going to do is the exact same thing, but instead of going through the API gateway setup, now there are a few limitations on what I'm about to show you. For one, this doesn't work with containers. For two, you can't CNAME this. But if you don't need to CNAME it and you can just use a big long host name, then we can hop over to Lambda again without doing anything on the API gateway. And fortunately, they were consistent with the request payload format here. And if I hit the function URL here, then you'll notice the Lambda URL is a little bit different there. It's .on.aws. And we get the same response back. And if I do that, then we have the message pushed back as expected. So that there is consistency in the format between Lambda function URLs and API gateway. So I'm glad that at least those two teams at AWS actually talked. So with that, so we've got SpongeBob via API gateway and Docker. So in that case, realize we're running short on time here. We can create a function here using a container image. And can use this nice browse function here, grab the latest one. And I actually built this on my machine, so it's ARM64. We don't actually need to do anything with the execution role because we're just running this on HTTP. Create that function. And then we'll do the same thing with API gateway that we did before as soon as this loads. Go here, hit the go button there. And we'll notice once this gets set up that this takes a little bit longer to initialize, but it's not too bad. So same deal. You can look in the repo to see what all I had to change. The Bootstrap looks a little bit different, but there is a standard kind of Docker file in there. Finally, realistically, all the stuff that I showed you with the Bootstrap stuff, don't use that in production. Use Bref instead. Because Matthew Napoli has spent a whole ton of time actually making Bref production ready and serving billions of Lambda invocations on it. So use that instead and find him because he's at this conference. To give you an idea of how much easier that is, this will take a minute, but it's using serverless framework, which, yes, it's a node thing. You'll have to run npm. I ran it ahead of time because I don't want to sit here waiting for npm to install. But this uses CloudFormation and API gateway and such to build out Lambda executions there, and you can actually use standard kind of PHP FPM setup within this, or you can just respond to events directly as well. So once this runs, we will get an API gateway URL back. We'll throw that in the browser and see that that does, in fact, work. The branch I'm on right now is using Bref 1.7. Bref 2 is currently in beta. Played with it yesterday, and it cleans up the config file format a bit and does a whole lot of under-the-hood improvements. So I figure that'll be available soon, but you can't go wrong here. So with that, I suppose we have a couple of minutes for questions, and while I'm taking questions, once this actually finishes doing CloudFormation things, then I'll show you that it has actually worked.
Okay, there was a question on Discord that came through. So regarding the custom runtime Lambda, what's the support level for custom runtimes in CloudFormation? Is it all doable in an infrastructure as code setup?
So short answer is yes, because the way that Bref works is it's using the serverless framework, which is using CloudFormation.
And any other questions from the room? Okay so far.
And so that did finish running. I go there. And again, we see our prompt for providing a message there. And again, all this code is available on GitHub. The last slide in this presentation, namely here, has that information on it. So I suppose that is all I have. Thank you so much for your time and attention. And if you have questions about this presentation, feel free to find me through the rest of the conference. If you have questions about Bref, then you should find the person who built most of it.
Thank you very much, Ian. We've got a quick room change. Just as a reminder, the TBC in your program, the correct information is on the website, but it's Dave Liderman with extending the PHP language with static analysis in the King Vault. Vigal, correct? Yeah. With file system management with Fly System. Over to you, Mark.
Thanks everybody for being here. Mic check. Mic's not, oh, there we go. Okay. If you want to follow along with the slides, they're already posted on SlideShare. There's the QR code. You can scan it, grab the URL, give you a moment to do that if you'd like. But again, they're on SlideShare. If you look for Mark Niebergall, it's really easy to find that talk and many others. You're in the Fly System talk. If you're looking for Pauline or Dave, they're somewhere else, not here. Yes, we'll jump right into it. First off, big thank you. We're on the last track, Thursday afternoon. Big thank you to the organizers, delegates, everyone here, speakers I know put a lot of time in, sponsors. The company I worked for, Nuclear Security, they did their part and paid for me to come here from the States, and we have a lot of great sponsors. I've had fun going around the sponsor booths, talking with everybody, learning about their companies. I even got an elephant. I'm pretty excited about that. Got some good sweets and treats to eat. And PHP community as a whole, big thank you, an amazing group. My experience has been attending a conference. I love to learn, network, get to know some new people, catch up with people I know from the past, have some fun visiting, playing games, whatever, and take what you've learned and apply it. Start using it. Find practical ways to implement things that you've learned or been exposed to, and improve your organization, improve your projects, take those skills and techniques and use them when you leave here. And again, congratulations, you made it to Thursday afternoon. The food has been amazing. I may have had like 3 of those cream caramels. They were so good. So again, thank you everybody. Quick poll, who is using Fly System? We're just gonna do a quick blind poll. Got about a third, maybe half, so okay. Just want to kind of gauge audience where we're at. Has anyone ever been snowmobiling? No? I don't see any hands. Okay. I live in the western United States, in the Rockies. This is a parking lot about 20 minutes from my house. Went up with my brother-in-law. I bought these older snowmobiles to go along with a family collection of snowmobiles. This was the maiden voyage. We got up on a trail, and there's a tree across, and my brother-in-law rides across first, and his snowmobile rolls downhill into the deep powder. It did not go well. Let's just put it that way. Snowmobiles weigh about 500 pounds. I don't know the conversion for stones. It's about 3 times my weight per snowmobile, per sled. And they are heavy. You can't just like pick them up and move them. I ended up having to abandon the snowmobile overnight on Mount Timpanogos in Utah, American Fork Canyon, and had to come back for it the next day because I left my hand winch in my car. I had brought the gear with me, but left it in the back of the car, and it was impossible to pull this thing out of there, and so it actually had a burned belt and some other things going on. It made it kind of complicated the problem. So we ended up having to bring this hand winch and extra tow straps and crank this thing up the hill out onto the main trail again, because that time the snow was kind of soft. Anyways, it was a fiasco. Long story short, the snowmobile made a home eventually. It was spent only one night on the mountains. I was very happy to have it back. Sometimes adventures don't go the way we had planned, especially if we don't have the right tools, and other problems come up. So one does not simply lift a snowmobile. I've been watching Lord of the Rings again. It was amazing. I loved it. So I had to throw that one in there. How do you effectively manage files with code is kind of a question that comes up. It's a very common problem in software engineering, very common issue to have to address, and I've seen many solutions. Some work great, some don't always work. Some I scratch my head at. I'm not sure how they work. But hey, it works. It's PHP. Sometimes it does that. It's kind of a question to think about. How do you manage files? How does your project work currently? Often there's some common solutions we see, such as fopen, right? You open it up the file, you get back a resource, you do some things with it, and write files or whatever. Maybe you're using like file get contents if you just want to grab what's inside that file and read it and do what you need to do with it. Maybe you're using that in conjunction with file put contents to push the contents back out. And then you're deleting the file off the file system because you don't need it anymore, so you're just using delete. Or maybe you need to use chmod to change some permissions or whatever. Pretty common, pretty kind of standard quo there of what to do with files. But if you've ever written files, you'll know one does not simply write files to storage. There's always problems. Every time I've tried to write files to storage, it blows up. PHP gets errors, gets resource errors, which are not super helpful. And you have to end up debugging it and trying to figure out what's going on. Files come in all sorts of file formats and sizes and permissions, and there's always something new that comes up. You get past one hurdle, and there's yet another one you have to go past after that. And so one does not simply write files to storage. It's always more complex. It takes more time. There's always struggles and issues that pop up. Just like me showing up, going snowmobiling and not having the right tools with me, writing files to storage is hard without the right tools in place. Not having the right tools with you and knowing how to use them and being able to use those tools effectively to resolve your issues or resolve the problems that come up. So here's the common problem we have, right? Let's say you have a file. You need to write it out somewhere. And in your code, you think maybe I'll have a local file service, an in-memory service. Let's say you're writing out to Amazon, AWS. You've got something going out to, someone's using SFTP still. They have an older customer maybe that is a little behind the times. Other formats, whatever. And then you have each of those individual services. I call them services. Some people call them other things. And they then go do that one thing. They do it well, right? They go right out to the associated file storage location. So your local files, your local service is going to write out to your local server file system. You have something that's writing out into memory. You have something writing out to AWS. And so that's the path we have. We have a whole bunch of classes associated with that. We have a bunch of code paths going on, and it gets complicated. There's problems. You have to write tests for all these. That's where Fly System comes in. So their quote from their webpage, Fly System is a file storage library for PHP. It provides one interface to interact with many different types of file systems. When you use Fly System, you're not only protected from vendor lock-in, you'll also have a consistent experience for which every storage is right for you, whichever storage is right for you. Okay? So in a nutshell, this is what it's saying it provides. We no longer have code written out individually for the different storage locations. We now have the file that's going into Fly System, and it's then writing out to wherever it needs to, using various contracts, interfaces, and supporting packages. From a developer standpoint, we only have to worry about configuration into Fly System, and the Fly System knows how to write to the different places we needed to get this file. That makes my life so much easier. I don't have to worry about figuring out how to write. The most common one, I'll use AWS because I use that one the most. It's super complex. If you ever try to write into AWS raw, we'll say, if you're trying to write Guzzle using Guzzle directly, There's so many different layers, there's different permissions, you have roles going on. It's so much easier just to configure it, pointing up in fly system, and let it take care of what it needs to do. And the file can be happy and go on its way. The objective here, walking out, I want you to be familiar with fly system and know how to use their API, their code. Have some ideas or concepts of how you might be able to implement this. And if you already have it implemented, hopefully I'll go over some new API, more edge cases or strategies that will be helpful in improving how you use it. So we'll go, that's kind of the strategies part of the last. The overview, we got adapters. I'll explain what the adapters are and what all they do. Exactly what the documentation, and also some, we'll call them hidden functions, if you step into their code and start looking at it. And then implementation strategies and testing at the end. It's kind of a classic, right? I won't get that working, but this little thing, if you remember this from like the 90s, downloading the internet, goes to A drive, and then it's like, you don't have next file storage space for it, right? And sorry, I can't get that working, but oh, there, it just went. Look at that. We'll let that go. That's an epic one. 42 or 41 kilobits per second, super fast. Sometimes faster than hotel Wi-Fi. Okay. So the adapters, they have, traditionally, if you think back to the diagrams I had, you have different code depending on where you're writing the file to that gets used. So you have your local service and your AWS service, whatever. And then you have, say, different code for each adapter, right? You might have different branches of code. Think about a use case. You have local for development. So as a developer, you're writing code and you want to be able to test this and run things. And so you're only using your local development machine, or maybe you're using a container or whatever you're doing. But then when the QA team comes in, maybe they want to use SFTP. And then in production, you're using S3 storage. So each environment or each server is writing off to a different place. And maybe there's a whole bunch of different types of files. So you have some JSON files, maybe you have some text files, image files, a variety of those that going around, being thrown around. Excel files, whatever. In my line of work, we have very large files that we're using, and there's a few different types, and so it gets kind of tricky. And so maybe you end up with something like this, of how you write files if you're not using S3 or any sort of adapter, or not using fly system. You have like a read local, if you have it all in one class, let's say, and it's returning file get contents. May or may not have some error handling on it. You have read S3, and it's returning it's going and pulling a file, and then maybe you're using a match on the storage service and going and returning based on that. Right, so maybe you're doing something like this currently, or maybe you've seen code like this before. This is where Fly System tries to come in and address these. You kind of start noticing patterns. We're passing in like just the location here. We know that it's returning a string contents. We notice that each one can have its own error handling. So we start seeing the similarities in the file management. Fly System is very configurable for local or external services. And so that's something to keep in mind as we're working through it. We'll go into some more details about some of the configuration, but keeping in mind that it's very flexible with where it's writing, and you can change that over time. So the official adapters that are officially supported, you've got local, so think of, again, if you're on the actual web server, it's going to be able to write out to the various directories that are actually on that server, or maybe it has a mounted drive or whatever. You're going to be able to interact with the file system on that local server. And you also have in-memory, so temporary files that are not going to be written to disk. They're just going through memory. They're going to be temporary. External, AWS S3 storage. You've got async AWS S3. You've got Azure Blob storage, Google Cloud storage, SFTP, Web DAV, which is a protocol. So you have a variety of options there. And also GitLab. I didn't know that GitLab actually had file storage, but it does. And it's a community adapter that you can use with Fly System. There's a handful of decorators that we have. There's a read-only decorator. So once you get your adapter, so let's say you're using the in-memory file system adapter, you can go and say, let's make this read-only so we don't mess ourselves up by changing something we shouldn't be, and make it read-only. And so then you have a read-only adapter, and then when you instantiate the file system, the Fly system, you are just saying, hey, use this adapter, and it's read-only. And then you're not worried about accidental file updates or deletes or whatever. So then you know it's read-only. It's not going to mess with the files that are being interacted with. It's a good safety net to use, depending on your use case, of course, to make sure that you're using the read-only decorator if it's applicable or makes sense. There's also a path prefixing decorator where you're specifying that you say, this adapter, we're just going to use this specific directory, and we're not going to traverse outside of it. We're going to stay here, and it's really good to limit the scope so you're not wandering or meandering where you shouldn't be, to make sure that the file interactions are in the right place. So if applicable, and oftentimes it is, it makes sense to use this decorator with your file system. All right, so that's kind of the quick introduction to Fly System. We'll jump into their API. I can't tell you how many times I banged my head against something and trying to figure out, scratching my head. Finally, I go and read the documentation. It's like front and center. This is how you do this, right? This is how you address this problem. I don't always read the manual, but when I do, it's because I've already tried everything else. So I thought that was perfect for this. I would say the documentation is decent. It's not the best documentation I've ever used or read, but it's there and it's decent. And it's enough to get you going and moving along. Big key note on that, big asterisk on there. Make sure you're looking at the correct version of their API. It's easy to get onto the wrong version and be looking at an older format, and then realize later when you're trying to figure out why it's not documented is because you're looking at the wrong version. So make sure you look at the correct version of documentation, and that will clear that hurdle. All right, so we'll start with exists. So you have file exist, and it just gets a string location of the file, and it will turn back a Boolean true or false. And this is where the beauty of Fly System comes in, is that this is a function that's on all adapters. So it doesn't matter whether it's an SFTP file, or a local file, or an Azure, or Google Blob, whatever, you're going to be able to just ask and query, does this file exist? And Fly System will return back that Boolean based on that location. Not having to go write code for all the different adapters, it's on all of them. Directory exists is another one. So just passing the string to the directory, and we'll find out whether that directory exists and is available or not. There's also the has, which is behind the scenes. It's just a file exists or directory exists. So then you can send in has for files or directories, and it'll tell you true or false if that if it does have that or not. It has your basic CRUD, so read or create, or write or create, read, move, and delete. So you write, that's kind of expected, kind of looks familiar. There's a string location, where you want to write the file out to. There's the string, the contents, and an array for configuration. We'll go into the configuration areas later. Most of the time, you don't need to worry about that. There are some exceptions, but most of the time, it's not something you have to set. And also write stream. Write stream is super helpful for large files, or if you have issues with connectivity, perhaps. So streaming files is a consideration, depending on, especially with larger files, is what I have found. That's been my experience. Or if it's a service that may go down occasionally, or it's not super reliable. Anyways, writing stream is helpful too. It's the same parameters passed in. Read. Similar to write, we have a read, that's just a location, and a read stream that returns, I missed that string, but you have delete API, which is just to delete the file. Again, if you're like on read only, you're not going to be able to delete the file. And delete directory, used with caution is a good way to put that one. A good word on that one. To be able to delete a whole directory, maybe if you're writing out to a specific directory temporarily and you've processed through all the files, this may clean up the directory after you're done. Those kind of things. With create directory, so being able to create a new directory, which is pretty common when you're working with files. Maybe you have a unique ID or some sort of hash or something that you're writing out to a directory. Let's create a directory and then a list contents, which can be very helpful. No more having to go and grab the metadata for the directory or for each over that. It's got a directory listen, which implements an iterator interface, and so you can for each over it, get an array, whatever. But it takes care of that, and also has a option for deep or shallow. So depending on if you want to iterate down into the subdirectories. Move. These ones, we're going to get into the mount manager later, and these are where the mount manager really shines. So kind of store that thought. But for moving files and copying files, as you'd expect, be able to move a file from one place to another, or copy it, leaving it in place, and putting it in another new location as well. There's also metadata, different API functions you can use. Last modified, get back a timestamp when it was last changed. Super helpful for processing files, or maybe you have some sort of customer that's uploading files to you, right? You want to make sure it's not still changing. File size, MIME type, checksum to ensure that one returns the hash, the MD5 hash of the contents of the file. Permissions, you have the ability to set visibility, and the visibility will return just what the current visibility is. You have URLs, so public URLs for like your S3, if you want to be able to access that for Azure. That applies to S3, Azure, Google Cloud, and Web DAV, and also the temporary URL. I don't use these ones very often. I'm not super familiar with them, but they're there. Frameworks. This is where we start thinking about implementation. It is bundled already with Laravel. It's available with Symfony, so it can be added on, plugged in, whatever. And it can be used with other frameworks. I've used it with Laminus as well before, or Zen Framework. So if it's not bundled in, it's most likely available to be used with your framework. Some implementation strategies. And we told them implementation would be easy. That's the story of my life with development. It always takes longer than I think it will. It's always harder than I want it to be. But we as humans are really bad at estimating, and and figuring things out, but yeah. So we'll go over fly system configuration settings, exception handling, wrappers, and mount manager, as I've alluded to already. Fly system is very configuration driven. And so you can inject different configuration for each of the adapters. So local is a fairly easy one. It's just the directory. AWS, you might have your key and your secret, maybe which region you're in, which version you're using, the bucket you're on, and so on. Each of these have a different configuration. That's honestly the hardest part. Their documentation does go through and list out the different configuration array key points, the keys and values to use, and a little description of what it is. And so each one you have to go and figure out, look it up, and use it and plug it in to your adapter. They're usually not too hard, but you just have to know those, what those configurations are. The big bonus of the configuration is that the application becomes more flexible. And you can have, for example, your configuration might be coming from the database, or it might be from your configuration files, whether those are PHP or other. So for example, maybe you have a UI where customers go and configure their file systems. Maybe they have a whole bunch of different accounts with different adapters, and so they can go and configure those, set them up, which brings in the scalability. So now instead of having to go and write one at a time, you're being able to store slate in the database or some sort of file and have the scale out to meet your demands from your customers, whatever your project's working on. Exception handling. There are a lot of exceptions that can be thrown through fly system. Something to be aware of and be prepared for. But it turns out to be super helpful in troubleshooting very distinct issues that are happening. Because as I talked about earlier, file system management, it can be very tricky, it can be very difficult. There's all sorts of nuances that can pop up. And so they have really good exceptions to be able to handle what needs to be handled. There is a generic one, file system exception, but there's also very specifics like unable to read file, and unable to delete file, unable to check file existence. This is just very scratching the surface, but know that there are many, many exceptions to handle. And there's the link if you want to go look at them. As a general strategy with fly system and exception handling as a whole, you want to catch the specific exceptions and handle them in your code. Maybe it's some sort of log or some sort of alert. If a file failed to upload or to be sent off or be written, you might want to know about that. And so however you're logging, however you're trying to alert on those, or whoever needs to be alerted for those. And then throwing some sort of meaningful exception that can be usable. So if a customer is trying to, or a user for your application is trying to upload a file, they don't want to see, we shouldn't be showing them what's going on behind the scenes with where the files be written. But if user-friendly sort of exception message of why, try again later kind of thing, if we found out that the service is down. Or maybe contact an administrator so that we can get alerted and know what's going on, even though we've already been alerted potentially. For example, if we're trying to read a file, we have the location coming in, a try on getting the contents, so file system read from the location. Again, this is any of the adapters, which is where it's super clean. Catch unable to read, and then catch a file system exception, where the unable to read is a more specific, more granular error, and we can handle that one however we need. And then catching the more generic file system exception, which the other ones extend, and so being able to, if there's something different went on, something kind of wonky, something we're not used to seeing, and then returning the contents back out. Wrappers or facades. There's some debate on the terminology, but I'll just use wrapper and facade interchangeably. Abstracts away, and for me this has been super helpful. It just makes it so the package we're agnostic to the package. And so, for example, you might want to have some sort of file system service or some sort of file system class that is not specific to the vendor. In this case, the package would be fly system, but then fly system is also being able to has all these different adapters being able to come in, and so when we swap out the packages, it also makes unit testing actually possible. Using what I'll call the legacy or old way or the straight raw way of interacting with files is not easily testable. We'll say it is testable technically, but there's some kind of nuances into doing that. So for example, if you think about wrappers, file system, but extends out to maybe an email service. If your system needs to send out emails, you make some sort of generic email class that actually does the sending of emails, and it doesn't care who your provider is. It just knows that it needs to send out an email. Or maybe sending out SMS messages. We have, for example, we have Vonage as one of the sponsors. I downloaded their API and just made like an SMS service and tested it. I was able to send a text message out using their SMS service, where I injected it as a client, an SMS client. So that was super clean. Databases. So you may or may not notice, or might not have thought about it this way, but using the database, you're using essentially an adapter or a wrapper, I should say, around your database layer, where we're not instantiating or using databases all over the place. We usually have some sort of centralized way to interact with the database, some sort of database service or adapter, and we're using that to write out to the different databases. So whether that's Postgres or MySQL or Oracle or SQL Server or Single Store or Mongo or ... down the line. Another good example is a queuing system. If you're using messaging for queuing up new messages, you might have a wrapper around that. So just kind of a more broader concept of using wrappers within code. So you have one place to do these. And so the benefit there is you have a centralized code. You're not having many different files. It makes it so much easier to test. And if you need to replace it sometime in the future, you just go to one place and replace it there. I've had to go and do vendor changes, like for email providers, or with actually faxing back in the day. And it was a nightmare because that was distributed out along the code. And so I took that and made it compartmentalized into one central place with a wrapper. And from then on out, we actually ended up changing the vendor again later and made it super smooth and clean. So, for example, we have class file storage service. Just generic, right? It could be used with anything behind the scenes. In this case, we've chosen to use fly system. It says file system because it's namespaced. Public function read, and it's just going to call the file system, which is using fly system, and do its reading, right? So here we've created this wrapper for the file service or file system. I keep interchanging those. That's hard. That's tricky. This is where we get into the beauty of the mount manager. So the example here, maybe we need to be able to grab files from one service and write them locally, right? So maybe a customer drops files in an SFTP, and we need to grab those periodically and write them locally so we can ingest them, parse them, process them, whatever we're going to do with those, right? Maybe another scenario is we need to be able to move files between adapters, right? So we don't know which those adapters might be. It might be WebDAV or an SFTP or a S3 or wherever. It needs to be able to bounce around between different places. Or maybe we have many customers, and we create reports locally because we have the database. We store those locally, we create them, and with maybe a messaging queue, and then those reports need to be delivered based on the customer configuration, or project configuration. So we don't know where those are going to go. It's based on some sort of config. And they need to go to a variety of storage locations. So those are kind of some scenarios where the mount manager comes into play. What the mount manager does is it interacts with different file systems at the same time. So you specify an adapter and a location. So for example, if a mount manager has been configured with S3 and local, it can now move files between the two of them. It can now copy between the two of them. It can go back and forth. And so you just specify AWS S3 or local, depending on how that's configured. Going back to the SFTP example, so you could write from S3 to SFTP. So now we're just doing it in one hop, rather than having to go out and do this all over the place. So it's super helpful for condensing down your file management so that it's centralized in one place. There's my amazing image. The arrows are perfectly lined up as normal. Okay, they're not. So you can think of the mount manager as kind of this central thing that's sending out files back and forth, writing it along. It can go both directions. It's kind of a visual representation of what I was trying to explain. All right, so we have our file manager. This is an example of how you might write some code with this. You inject the mount manager. Ian Lippman had a great talk earlier today about dependency injection. This is the constructor injection pattern. But it's written in PHP 7.4 style, not with PHP 8 plus property constructor promotion. Anyways, so it can then read this from the mount manager, right? And so we don't care which adapter it's coming from. It can read it from wherever. Maybe it can move things or wherever. But then you need a file manager factory. So now we start getting to the factory pattern. We're going to go and create, it just creates a bunch of different mounts, we'll say, or configurations, where each mount is a different adapter. And so we're going to add these, just push them on, right? So FSPP, maybe it's Google Cloud, maybe it's Azure, maybe it's whatever. And so we're just going to start pushing these onto the file system, or the adapter, the mount manager. And so now the mount manager can go and now we can access these different protocols, these different locations, these different adapters. And then maybe we have a factory beyond that. So this is kind of a little cascading effect there that happens with the mount manager, so it's a little weird. But when you plug it in this way, then we're able to go and create these different adapters and shove them into this mount manager and go on our merry way and have it all taken care of in one place. So AWS S3 and local, those are as mentioned, the protocols. That's what I was talking about. You reference the file with AWS S3 : / and then the path and local : / Anyways, that's how you configure where it's going to be going. And we say this is going to this adapter. Testing. This happens all the time, right? Read the docs, make a plan, write the code. Code fails. Okay. I think my code fails more than it succeeds. But getting it there, once it gets there, right, then we're all happy. So as I mentioned earlier, historically, testing file management is difficult. Often we end up with various test files in our code base to do this. or we're injecting, making up file content. Maybe you have in your git ignore file, like ignore these test files directory. We're skipping, we'll just skip it. We'll just kind of turn a blind eye to it, ignore it. And then we have integration tests versus unit tests. So often we'll end up doing integration tests or end-to-end tests rather than unit tests specifically for when you're not using some sort of adapter. Because there's not a way to okay, technically you can, but yeah, we're not overriding these built-in PHP functions. We're having to use fopen, for example. So you end up with something like this. You have this test read, which has a file. It says this file is an actual file on the server or on the system, and it's going and reading this file, and then you're asserting that the contents are something that you've pre-typed into this text file that you've created locally. So it is, I consider these integration tests. There's some arguments about the naming, but anyways, integration tests is what that's ultimately doing. The file system abstraction layer gives you the ability to actually test what's going on without having to make up files locally. And so you can start mocking these file interactions. Your code is becoming more single purpose, which is the S in solid. And then you're having a more centralized file system management. So it's really helping push for these best coding practices. So now we end up with something like this. This was written with just the built-in PHP unit format. I also use mockery and prophecy, but I kept this one clean. So you have, for example, a test path. You just make something up. You then mock the file system with the file. Just use the git mock builder. Just throw on a disable original constructor, saying we're only going to mock or only methods read, and you want to mock that. And you say when the read is called with the path that we just created, this made-up path, that it will return some pre-specified text. And now we can actually go and write a test for that and not have to actually interact with the file system. So now it's actually a unit test rather than an integration test. I consider a unit test something that is as a test that does not reach out externally to the system. So no database interactions, no API calls, no file system reading, like those kind of things. I think both are very beneficial and definitely are useful. But now with Fly system, we can have both, not just integration tests, but we can have unit and integration tests. Kind of some discussion items. I've given this talk before at Merge PHP, and I've talked to some coworkers and others about Fly system. So there's kind of these questions of benefits of Fly system. It provides that quick development to be able to scale up different adapters and be able to read out. There's also some, there's a question of cons too. I have heard the argument that then you're locked into using the specific package. I haven't really had that be a problem though. Generally, I like the benefits far outweigh the cons to me, especially with like the exception handling, the error handling, where that can get really tricky and convoluted with file systems. Security and credentials. Security should always be a question when you're going and grabbing third-party packages. Fly system is in the league of extraordinary packages. So it has very good code with good test coverage, good security protocols. So I haven't had security issues with it. And then there's credential storage. That's a whole nother day, another talk that I'm not an expert on. As far as credential storage and security or vaults and how to do that, but be very mindful of that as you start interacting with adapters of where you're actually putting your credentials, how you're storing them, how you're retrieving them. They shouldn't be just raw in your code, and you shouldn't be committing those in anywhere. Conversion costs, scalability, maintenance. I have used Fly system for about a dozen years. It's been used quite a while. I've mentioned I've used it with S3 mostly. I've used it to, it's very heavily used with pretty large files. We're talking thousands and thousands of files every hour going in and out of this. So scalability, I haven't had issues with scalability. It's really been more server capacity is the bigger problem I've run into. If you start running out of space on the files, on the server. The maintenance, they don't have a ton of versions released. I'd say it's fairly, they do have updates. They do make updates to Fly System, but it's not like super rapid fire. You're not, constantly getting burned by backwards compatibility and those kind of issues. It's been really easy for me to upgrade the different versions there. So we've gone over, again, the external services, which adapters are available. We've gone over the API, so you should be familiar with how to use it, whether that's reading, writing, moving, copying, grabbing metadata, checking the MIME type, doing a checksum, whatever. Some strategies like the mount manager, the adapter or facades that you can use for those, and how to actually write tests for these. So hopefully it gives a good idea, a good introduction of how to actually use Fly System, or maybe if you're already using it, you get some new ideas or new pieces of Fly System that you can go and implement. Go, as you head out of here, you can go create a user story, or however you're open a ticket, whatever your term you're using, to go and actually start doing these things. That for me has been the best value from going to conferences, is actually making these changes. I co-organized the Utah PHP user group. I love doing outdoors things. I'm always out and about. I write security certification exam questions and work on a vulnerability management project, or basically security scans. So basically we grab all this data, process it, analyze it, make trends on it, and so on. You can find me on Mastodon, Twitter, everything else on MB Niebergall. Yes, I've done a triathlon. That was so much fun. I've run marathons, those kind of fun things. And as I mentioned, I live in the mountains, and we have epic amounts of snow this winter. We've had a lot of fun skiing. I go fast and crazy down the hills. That's me in the orange coat. Get myself in trouble, going up jumps, whatever. And I co-designed the Zend elephant. That was back in the day. That's my personal favorite elephant. That will open up to questions.
Anyone? See any hands? You're obviously very thorough there.
Covered every question possible.
Oh no, we have one. We have one.
Hi, Mark. How do we handle the files? Some customers shouldn't access that file, so for other customers' URLs. Is that something that Fly System covers, or is it something that we should handle in the application, or is there any workaround in the Fly System?
Yeah, great question. So, how should we limit customers' permissions to different files?
Yeah.
Yeah. Fly System, I wouldn't say takes care of that. It doesn't handle who should see what. You can set the visibility, set the permissions, so if you're going to 777 the file, it's going to be accessible to everybody kind of thing. You can lock it down, though, with the visibility and the chmod on it, but it doesn't, you have to, that's the extent of its ability, or what it can do, though, is just setting the permissions on there. Like with some of the adapters, I've done, like I mentioned with S3, we've set up like roles and those kind of things where you use the adapter's permission system, essentially. So if you're writing off to Google or Azure or wherever, making sure that you're in the right bucket or equivalent of those to make sure that we isolate off the customer information.
Okay, thanks.
Yeah.
Any further questions? Okay, no, that's all. Thank you very much, Mark.
Thank you.
Leander.
This is not about learning not PHP. We've been at this conference all week. We've got stuff to dive into. So first, I want to do a shout out to the organizers, the sponsors, and the volunteers who made this conference possible. Thank you. And a special thanks to all of y'all. I'm showing my American accent right now. To all of you for attending. We could not do this without you. Thank you for coming. You all should applaud yourself. Thank you. So as a developer, we are expected to inhale new technologies all the time, from the latest libraries of PHP 8.2 and 3 to performance-driven development. You're probably going to hear some familiar things here. From dissecting PHP's type system to effective code review, from taking over a legacy project to rapid application deployment practices with Symfony. And throughout this conference, we've only touched on these things. So maybe you're inspired to take a deeper dive with these technologies. I personally am inspired by Diana Scarf's talk yesterday and the Laravel's project. I'm going to dive into Laravel. And in the interest of in the interest of full transparency, I'm a Python developer, but I have touched PHP before. Early in my career, I was a PHP junior developer, and I was just starting to get into the weeds when the company went under. And then I went with a new company, and their language was Python. So ever since, that's where I am. But now I'm with Temporal, who has a PHP SDK. And then yesterday in Diana's talk, I was like, well, I could start to learn this new framework. So I'm going to talk about how I plan on learning this new framework. And I want you to keep in mind that this is not for just, this talk is not just for senior developers, because if you've been doing this for a while, you know how you learn, you're comfortable. But this is also for managers who have junior engineers and interns, and this is how you can support them. And this is also for mentors. And if you're at the senior level, please tell me you're mentoring, because that's how we bring up the next generation of PHP developers, is by supporting the young ones. So raise your hand if you heard something this week that you're keen to dive into. Yeah, it's a good conference. So I propose 6 tools in order to work more efficiently. And I want to say that these are the tools that work for me personally. Through years of experimentation, I have developed these patterns for myself, and I would like to propose that these might be completely wrong for you, but they might work for your proteges, they might work for your people, and you might experiment, or I might say something today and you're like, oh wait, I haven't tried that. I want to try that. So I let's not go backwards. I strongly encourage you to test and experiment with these and make them your own, and encourage the people you work with who are learning quickly or are uncomfortable learning to also experiment and find their learning style where they work most efficiently. So first, who here has heard of escape rooms? Yes, okay, so confession time. I'm a little bit of an addict when it comes to escape rooms. I'm doing one tomorrow, and that's impressive because it's the only one I've done on this trip. Before COVID, and I would travel a lot, in every city, country I went to, I would line up escape rooms every night and bring people from the conference. And I think we should do that again, don't you? Next year, we'll make it happen. So when you first get into a room and they lock the door, they don't lock the door, and they tell you a puzzle, they give you a framework, the first thing you do, if you've never done an escape room, this is gonna make you a professional, by the way. The first thing you do is you look for patterns. And so you look for things that stick out or that match. And one of the things that I do when I'm learning a new technology is I pattern match. So I have a lot of infrastructure experience, a lot of server experience, a lot of database experience. So when I was first learning temporal, it has a little server. And I was like, ooh, I know what a server is, I know what backend is, I know what the database is. And I was mapping the knowledge. And then I would go and make sure I was right. Hey, this is what our docs say. Is that right? Yes. Hey, this is what I'm assuming. Is that right? No. It's actually this and this and this. And what I'll probably be doing with Laravel is comparing it to Django Girls, which is a web framework also. And I'll be mapping my Python knowledge. I'll probably wake up next year and be a PHP developer, and sorry, not sorry. But I'm gonna map the familiarity that I have with Django onto Laravel until it doesn't help me anymore to unlock the doors and get to the next room and solve the puzzles. I encourage you to map what you know. You already know PHP, presumably 8.1, maybe older. So mapping to 8.2, you're gonna go, oh, this feature was enhanced, oh, this feature is gone. And you're gonna be able to lower your barrier for learning the new technology. All right. Open has two meanings for me. Open as in an open mind, and open as in open source. While you're working, this is a bit of a 2-for-1. I would strongly encourage you to treat any technology, whether or not it is open source, your learning path, treat that as an open source project. I'm not saying put it online and give it an MIT license. I'm saying learn in the open and encourage other people to learn in the open as well, especially with 8.2 and 8.3 PHP. Those documents are the minimum we need to get going. So there will be gaps in there, and so you asking the questions online is going to help not only other people to learn that information, but also encourage the project, oh, that's a huge gap, let's update our docs. I'm not saying it has any holes in it. Actually, that's exactly what I'm saying. But I'm saying we're gonna make it better together. That's the open source way. And yes, it feels a little awkward at first. You may be embarrassed. I don't wanna look stupid. I get it. Someone else was thinking the same exact thing. I guarantee it. So how do you ask a good question? First of all, don't just ask when you think of it in your head. Please research, because the answer might already be out there. So first you're going to research, you're going to be on topic, and you're going to be very, very specific. What are you trying to do? What's your goal? What are the specific steps to do that goal? What is the expected result? And what is the actual result? These are the 4 steps that we used to ask every person that called us when I worked at Red Hat. I work at Temporal now. I'm not in support. But it helped. Every troubleshooting question, every call that came in was solved very easily because, oh, I get you. I can reproduce your problem so much more efficiently than if you just come to me with a down server and say, it doesn't work, help. Okay, so what were you trying to do? How were you trying to do it? What was the expected result? Not a dead server. And what was the actual result? Then, please keep an open mind about what the results are. The results could be as simple, it could be a user error. I can't tell you how many times. It was an ID10T bug, which, by the way, that means an idiot. And it was me. I just misread something. And that's okay, because you're telling the project that something is confusing. So keep an open mind about what your answers might be, and please don't delete it. Even if it's super embarrassing, you can tag me and say, Rain said I had to do this, and I'll take the blame. Keep it simple. Okay, imagine, if you will, that you are learning a new technology like PHP or Laravel. I am not going to take those two, a language and a framework, I am not going to take it and then also add Snowflake databases, which I have never worked with, and Azure, which I have never worked with, and a fourth stack. I am not going to take all that complexity and learn it all at once. I am going to learn the minimum PHP Hello World and the minimum Laravel web framework. And I'm going to put it on things that I am really comfortable with. My local development platform and MySQL database for now, or SQLite. And I'm just going to make a little hello world. I'm not going to build a robust shopping cart. Because all that complexity with learning a new technology means that if something breaks, if you get an error message, I don't know if it's from the language or the database or the platform. It could be anything, because they're all new. Now, Googling it, researching it, I'll probably figure it out. But I have a story for later where error messages can be very confusing. Think of it like wheels of a bike, spokes on a bike. You wouldn't replace the entire bike if you were just trying to learn the technology of a single spoke. You would change and learn the technology of a single spoke, and then change another one once you're comfortable and you're biking. Then change another one. So keep it simple. Instead of trying to learn every feature of Laravel, I'm going to be learning the baby stuff, which if you want to come tell me about it, you're welcome to. I have already Googled Django versus Laravel and started comparing, mapping out my patterns. One of the things that I was told when I first got to Temporal was, I was like, I would like to build something, because that's how I learn. I build. I could read docs all day. I could watch your video, and I'd be like, cool. It's not sticking. So I was looking for an application to build for myself. And I was talking to other people for their opinions, bless them, and they were saying it's too simple because Temporal does all these things. And this is not a talk about Temporal, I'm not going into it, but it does all these things. And I was like, yes, but I want to do one workflow, which is the simplest thing you can do with Temporal. One workflow. And then I want to add one activity. And then I want to add a child workflow. and then signals, and then queries. I don't want to replace my entire bike wheel. I will crash. So we're using all these analogies. We did an escape room. Now we're on a bike. Where are we going? We're drinking water. Pardon. I also saw that in Diana's talk, and I was like, stealing that. That was brilliant. She did not chug, but. All right, keep it interesting. This is the other thing about the talks that I was having with other people. And I'm not saying don't talk with other people. Please talk with other people. The only way you can learn is through collaboration. But I was getting a lot of feedback about stuff that was really boring to me, like a background checker, which is really cool to like maybe a big company that wants to do a background check. But if I'm just learning a project, I want it to be a game. Catch the pattern? And I completely did want to build an entire escape room. But I was like, wait, simple. And I looked into the features, and I was kind of like, you know what takes turns and waits, which are 2 features of a workflow, is poker. And so I built a poker app, and I have a lot more appreciation for people who build poker apps professionally, because just shuffling a deck is really complicated. But I knew it was playful, it was a game. Once it was finished, I could, it was CLI, it's CLI based. I could shuffle and deal and trade out. It's just 5-card draw. I like it. I'm kind of proud of it because I built it in 3 days. But I kept it simple because but also I kept it interesting because I knew me. I like to game. I'm actually 12 years old. You can tell from the hair. I need some joy in my life. I want to play every day. I am the song. I just want to bang on the drums all day. And so when you are learning, please build something or experiment with things that you find interesting. You might be bored to death with poker. I get it. It's very complicated. But make it something you feel passionately about. Something that's like, ooh, I want to work on my garden. Ooh, I want to build an escape room database. Ooh, I want to learn how to ride a bike. Not as relevant. Something you feel good about. Okay. This is where it really gets about you. And drinking water, sleeping enough, pausing, going for walks, taking breaks, knowing your own learning style. These are all experiments that I can't tell you how to do, but I can tell you what works for me. As a developer, for example, if I code with no input around me, especially since we work remotely from home, no colleagues, just cats, the kids are at school, and I can go 6 hours without eating. Not healthy, by the way. So something I have to do is set the Pomodoro, or I will just go. And at the end of those 6 hours, I will be dehydrated and miserable, and no longer any information is coming in or going out. So if you find that you just zone out or that your people just zone out. Encourage breaks. Thankfully, we're in Europe where breaks are encouraged. Second, make sure that you kind of understand how you learn. Like there's a bit of a debate today in the education worlds between, there's the visual, auditory, reading, writing, kinesthetic, and there's kind of a debate about, yeah, but you just really need to pay attention to your environment and have kind of a merging of all four. I'm not here to debate it. I know that I need to do it. I also know, since I'm slightly ADHD and just go squirrel all over the place, that I need to read it one day and then come back and watch a video and then build something and then go back to those reading. And I kind of Pomodoro that. 20 minutes this, 20 minutes that, 20 minutes this, 20 minutes that, 2 hours of coding. 20 minutes that, 20 minutes that. That's what works for me, because squirrel. And then finally, I want you to take care of yourself, and I won't get too woo-woo here. This is a whole other talk in itself. Please get enough sleep. Please eat healthier choices. Drink your water, go for walks. Whatever works for you in your body and your brain. And this is the last tool. I propose, just like the Ice Princess said, to throw it all away if it's not working for you. All of these are not rules, they're hacks that happen to work for me. And none of this might work for you. Now, I'm going to do something very divisive, because I know y'all are brave. I'm just going to use all the princess references right now. Raise your hand if you like Vim. Raise your hand if you're an Emacs person. I forgive you. I come from VimWorld. Sorry, not sorry. And when I first started learning temporal, I coded out that Python, that little app, 3 days, no problem. All in Vim. I know how to exit Vim. And then I started layering temporal on it. And this technology is kind of complicated. You run a server, you use Docker to spin it up, you import the libraries, et cetera, et cetera, et cetera. And I put in a line of temporal code and got an error message. And I was like, is that from the temporal server or my Python app or Docker and with Vim, love Vim, not helpful sometimes. And so I had to break one of my rules of using just one new technology. And I had to add an IDE, which I had never used before, Python, PyCharm. And I was like, what are all these colors? I didn't even know how to install a library using the IDE. I had to look it up. And temporal has a plugin. I was like, oh, awesome. It's not that new. And then suddenly, all the error messages were very clear where they were coming from. Docker, temporal, connection, like very clear. And I was like, oh, sometimes you have to throw away all your rules and swallow your pride and get rid of Vim. I'm sorry. I'm not sorry. They say that it's not about the tools until it is. So try not to let the tools be your excuse and break rules. Now, I said all this, and I promise I'm not going to sing. Or am I? No, I'm not going to sing. I promise. I just want you to remember these tools. So look for patterns. Keep it simple. Keep it interesting. Keep it personal. You know I'm going to forget one of the rules. And then let it go. I promised I wouldn't sing. And you're welcome.
Rob.
This is me, that's Temporal, and that leads to the PHP SDK of Temporal. Isn't it pretty? Thank you very much.
Thank you very much. That was a great finish to the conference. Yes. Wow. I've lost Chris, so I'll do this on my own. So we've got some prizes to give out again. My very helpful helpers here. So these are from Platform SH, first of all. Do we have Thomas Freeman here? Okay, all right. Well done. We've got Mike Tipping as well. He's making his way down. Gabriel Liviu. Zuzana Kunkova. There you go, Mike. Yeah. And then we're going to try again with Mashid Hashgani from yesterday. Ah. Sorry to the backup name. You'll never know who you were. And Mariusz Soltis. Is that? Okay, you can hand that over. Hopefully we've also got Chuck, is it, from Vonage, to come and hand out their prize. There you go. Take that.
Thank you. It's not on.
Do it now.
It's on now. There we go. All right, I have the very last Alex to give out. Thank you, everyone who came by and stopped by and signed up for it. So, spinning the wheel here, I have Fola Aziz. There we go. Yes.
Extremely rare.
Extremely rare.
Yeah.
Yes. Here you go. Hold on. Wait. Wait. We need a selfie. What's going on here? Oh, okay. Why am I in video mode and not portrait mode? Good deal. There we go. There we go. Congratulations.
And I believe Temporal, you're going to send yours. Yeah, okay, brilliant.
Adrian Pennington.
So, Adrian, sorry, you can take. You can. We're going to ship it to you. So that's the programmable pixel art Bluetooth speaker. Thank you. You want to come? Thank you. Found my Chris. There you go.
Hello. Duty called.
So just some thank yous really to wrap things up. So thank you to all of our speakers who work very, very hard to probably spend days, weeks. I've never done it myself. So it takes a long time, I guess, to put a talk together, right? 3 people in particular who've helped us out at the last minute when speakers have unfortunately been unable to make it. And they've given us 2 talks. So thank you especially to these people. Thank you to all of our sponsors, of course. Hopefully you were able to interact with them today. And then to our team as well, I'd like to say a thank you to them. A number of them are actually highly qualified programmers who we drag up to London every year. They work for me and Chris to pack hundreds of delegate bags for everyone, carry boxes around, load and unload vans. So thank you to all of our team as well.
Before we move on, I just want to say, I don't think anyone's ever had a chance to say thank you to Sam. I mean, these events exist due to Sam. It was a brainchild of Sam from the start, so we all owe it to him. Thank you, these exist.
Thank you very much. Cheers. And then again this evening, as our last speaker, Rain, said, thank you for coming. For some of you, over a decade, I think. See the same names popping up, so thank you for coming back over and over again. We've got a few goodbye drinks downstairs. Thank you to Chris for co-hosting with me. Have I just taken you away from a deployment or something?
Oh, no, it's fine. We're just doing a site map. So.
Oh, okay. That's unimportant.
Not to the client.
Well, I'm having a beer. You can go and carry on with it. So yeah, we've got some drinks for you downstairs, just for the next couple of hours, and then yeah, hopefully you can grab people and go for dinner afterwards as well, and you've made some friends that you're going to see again next year. So thank you for coming. Please, hope to see you next year. Thank you.